know.
That's
I have to keep that. I know. She's
so-
did so much work. Oh. I mean, she's only in 6th grade. She's been doing this for a couple of years. She ran this show, I swear to God. She got all the equipment every time and then organized and worked at the scheduler. Yeah, because I've always been out there. Yeah, I'm really proud of her. I guess I can take a little credit. But she did all of this. I showed her once. I was in panic to train her. I didn't know her town. She's like, she's in 6th grade. Yeah, she's like, can you show me how to, I have to break from the inside. Yep.
Yeah, that's looking really good.
All right, cool. Great, thanks.
Hey, bud.
How are you?
We're competing with whales right now.
I know.
Oh, it was so cool.
Right? I'm like,
Yep.
I'm getting texts from friends. I'm like, there's whales. I'm like,
Right. That's a cop. Let me guess, Cam's
Let's hope it
2017.
says something about cams or OA or.
hmm?
Oh, that's what it talks on there.
Okay, well, no videos or links or
I
animations.
don't go there. I've learned that lesson hard
I know,
too many
right?
times.
I've even learned from others not to go there. Actually, I don't know how to do it, so I haven't tried.
You guys aren't publishing these or anything, right? I got all sorts of data here I can't give out.
Okay, let me know that. But,
Okay,
I
just
mean,
ask this talk.
Okay.
You
That's good
really
to know.
want something on
I was
the web?
gonna, no, I
I'll
would,
pull it up,
because we
give
were
you a
gonna put it
PDF
up there,
with
so
that.
we won't.
right, I was going to ask the presenters before, although Teresa is live streaming it.
I am in
Yeah, that's no problem because I do it in a talk, but
But it's gonna
it's
be on
other
YouTube.
people's
Okay.
data, that's fine. It's other people's data.
Okay, I was going to put a call out to everybody to make sure.
It's not that huge of a deal.
I know,
just have a
but-
couple colleagues that I have brand new stuff in here. Just
Yeah.
no big deal.
You wanna look and make sure it's okay? Because I think that YouTube video will be
of the it's part of the presentation.
Okay.
So the context is there as I say it. But if someone grabs up some of these data out of context, for instance, this is none of this is published. So then out of context, it's so that's
Just did that, huh? People that.
I was gonna ask everybody before. I've
yeah,
had,
you know,
I've
most
had.
people are going to be completely fine with it.
Yeah.
All I'm going to do is take
Yeah.
that one slide out and a PDF for you.
Okay.
But yeah, no worries. It looks great. There you go.
Great.
That at the top. These two talk great there.
Oh my gosh, wasn't it?
Aren't they amazing? I was
That
like,
cool stuff. I heard you
wow.
say that. So I didn't know you guys were doing all that.
I really did.
That scratches the surface. There's another 10 probably topics that they're working on right now. That are like,
Great thing.
I want them to help me. Well, do you know Will from Accent? I wish he would had, this is Will here, he stepped in after and after. That's great.
great.
Kids are doing that.
Yeah. Absolutely.
Because I can't do it.
That's great.
I was pretty impressed.
It's super impressive. Yeah, the program is incredible. I mean, it's one.
I didn't get the, is it talks in class?
It depends. No, it's all over the board. So sometimes it's just like this after-school thing that occurs. Sometimes it's incorporated into the like in the middle school has a couple of kids involved in one of the projects in the classroom. So it's all sorts of stuff across the board.
Hey, Sable, look at your lot in here. Sable, have you seen Bobby?
Yeah, it's really fun.
So Julie, did you have
Talk to you
your?
across the room.
I just gave it to you.
Is it on this?
Oh, yeah. They're all bored. Come on, Sam, you gotta go out.
Sweet pie? Sweet pie? Sweet pie?
She did, how are you?
I was almost hoping it would rain today.
I was waiting for rain, I've been begging for rain all
Careful,
week.
it's gonna rain below 45.
We've got like 6 days of it coming, you know, which is looking because I wanted to take my back. I was very jealous of watching people get sent out yesterday.
I've been building this deal out there in the greenhouse. I saw the rain forecast, so last night I stayed up till midnight, banging nails and putting it together and getting the last touches on before it comes down.
Oh, good. Did you get done what you wanted to get done?
Yeah, at least enough of it. Yeah. No, I said that. Yes. Good. Excellent. Yeah, that was good stuff. You guys hadn't met at all. Well, that project has been interesting. It's been done so far. Are you all ready? Moving forward. That's exciting.
Yeah, rain or shine. Let's see. Yeah, the calcium looks good. That's what I don't know.
I got a bunch of projects in the South where are you gonna leave them stuff?
We're waiting for, the results.
Well, they are. Patient of Monday. Maybe I should ask them to say that like this. We're not. Brought donuts.
How much more? Because maybe you
Post it online, you're filming on YouTube.
Yeah.
Okay.
So we're.
Yeah, I was getting a meeting from it and thank you, Chris. Thank you.
So you're streaming this out?
Oh, yeah, yeah, you should talk to, I don't know.
Well, it was just a surprise.
Is it out to the girls?
Couples, you're on this one. You got your crew tomorrow?
Yeah, yeah.
You seen all they made and stuff? I was gonna say, you wanna go over and see the lab? We've got the almond milk, scrap, we've got all the
Everybody wants to wait until. Now we have to. Sorry.
Some, yes, yes, yes. Oh,
Calling it. Yeah. No, I don't know.
Good afternoon, folks. We are the strong and hardy. We come in out of the sun and the whale watching and all those fun out there. We're going to start up real soon here, so grab your seats again. Stay patient. It's got a few more hours to get through. I know that the Elliptic Museum tour might not be completed, so maybe we'll have some more folks trickling back in. All right, we're going to continue with our community and monitoring session, and I'm going to turn the session back over to Teresa.
Thank you, Julie. Thanks to those of you who wandered back in out of the sunshine. I think we're looking ahead. We've got a good, solid Kodiak rain coming forward, so our northern rainforest will be coming back to what we're used to. But I'm glad we have folks here. I think some folks will be wandering into after lunch. So next up, we have Peter Windsor. He's going to be talking about coastal community ocean observations. And let's see, is Pete in the room now? There's Pete. Hi. Thank you and welcome. Thanks for coming.
Thank you. Thanks for showing up after lunch in Wales and sunshine. I'm here to talk briefly about a program that's we've been going on now since 2014. It started out in St. Paul Island, and it's a little different flavor from what you heard before earlier today. We focused very early on collecting the highest possible quality scientific oceanographic data in the nearshore environment to assist other programs, to assist communities, and basically take it from there. We're funded by the North Pacific Research Board currently. We have a proposal in to continue this. We have other funding avenues that we're working on, and I'm going to tell you a little bit about this project. Currently, we are operating in Old Harbor, just down the road. Me and Tula Holman, who's at the Sea Life Center, we were there yesterday. Had a beautiful boat ride and worked with the local school in Old Harbor. They've been taking C2D measurements down there now for quite some time, and they're producing this amazing time series of best possible scientific ocean data. We have partners in St. Paul, Kodiak, and we are starting up in King Cove with a high school in King Cove and the native tribal offices in King Cove as well. To give you a little scientific backdrop why we think the coastal zone around Alaska is severely undersampled. If you're like me, a physical oceanographer that does big proposals, we typically end up on very big research vessels such as icebreakers, such as the Kodiak or the Healy or any of the UNOS vessels, and we stay well clear of the coastal zone. One, the captain gets nervous, he doesn't want to go there. Two, we have this agenda of mapping the whole world and be very big-headed, so we like to do big science in the blue ocean. And this whole sliver of the coastal zone is typically forgotten in physical oceanography and marine biology too, even though that's really the zone where a lot of the action happens. That's where the terrestrial meets the ocean. That's where salmon migrates. You can list a long list of things why we should be studying nearshore environment, but right now I think we're mainly failing in that regard. So we wrote this paper that's sort of a framework a couple of years ago in 2015, which we call the riverine coastal domain, and we showed that this is basically a ribbon around the entire Pan-Arctic that's basically fed by the same physical processes. Mainly a river runoff, so buoyancy being put into the nearshore by rivers and terrestrial runoff and snowmelt. And that's connecting all these regions together in a ribbon that we think we should be studying. So on the right-hand right-hand side here on the next slide, you can see what that sort of riverine coastal domain looks like in a schematic up on the upper left. And then on the right-hand side here, you can see some hydrographic cross-section that shows this riverine coastal domain RCD very clearly in sections. And you should notice a couple of things. It can only be a couple of meters thick sometimes. And typically the rotation of Earth and other dynamics confine this region to sort of 10 kilometers within the nearshore region. That also means that's a problem to study this from space, because one thing is that we have a footprint of most satellite sensors aren't small enough to resolve this properly. And if you're interested in the biology of that, most of that biology is a subsurface biology concept that you can't observe from space. So there's a number of reasons why we think you should study the nearshore. If you send me or Russ Hopcroft out there, we cost a lot. We can only be out there on one snapshot cruise per year, even if we did go there, which we typically don't. So one really powerful way of doing this is to involve coastal communities that actually fish here, hunt here, subside here, and get them involved and do continuous, really good measurements over a long time to create a baseline, to be able to look at climate change propagation in this area and so forth. So we've been doing that in Alaska in one place only, and that's the GAC-1 mooring outside Seward, where we had a subsurface mooring and CTD cast at least once a month for the last 50 years. And once you start collecting a time series like this, you start to see these very, very large climate shifts in the ocean. Some of them are related to PDO changes, some are related to other dynamics that we understand fairly well. And each of these anomalies are directly tied to big change in the ocean ecosystem, including shifts in fisheries from shrimp-based to fishery-based, fish-based, and we have been able to take each of these anomalies and basically map out the change that's happened in the larger scale ecosystem. So having long-term consistent time series in the oceans are very rare. We have one in Alaska, and we think using the coastal communities, we can develop many, many more and understand northward progressive climate change. So last thing in this sort of lecture, we feel like I'm giving one of my physical oceanography lectures for you, but you're welcome. Is that another thing that people talk about is that we have regime shifts in our system and that we might be reaching tipping points and we're actually getting into a different system in the ocean. How do we know that? We don't know that unless we measure the same things over a long time. So if you're looking at sort of a tipping point theory or regime shift, there's a lot of talk about it, but actually we're doing a very poor job of collecting the right data to be able to determine if this is happening. People talk about trends and the ocean is warming. If you go back here, you can say, yeah, it's warming, but it's also cooling and it's in these episodic natures, and you might be able to extract a warming trend out of this. But really what you need to worry about is something like this, where you're pushing the system into a different state that's irreversible, and you end up in that state, and now you're stuck with that state. Whether it's good or bad depends on who you are in this marine ecosystem. So in our program, the Coastal Community Ocean Observers, we've been thinking about the physics of the system, but we're also starting to deal with how we can get into the marine ecosystem. So we're doing temperature, salinity, and fluorescence, which are CTD casts that the communities are doing regularly, bi-weekly or monthly. But we're now also starting to think about, with Tula Holman's help, how to do something that ties us to the intertidal and to the terrestrial. So we're thinking of working with bivalves, which are great, and we're starting to think about measuring phytoplankton concentrations, for instance. All of this is sort of great, but the only way you can really tie it into a community is to involve the local schools and the next generation. So for instance, when we've been to Old Harbor here in Kodiak, that's a good example. We're working with high school kids and they get super fired up about doing measurements in the place where they actually live. And we, each community, we try to cater to their own specific needs and interests. So in this particular case, they were very interested in some whale die-off that happened around there. So we bought them an electronic microscope and they're starting to collect plankton and figure out what was going on. And right now they're going to start up with this bivalve sampling protocol that Tula has been working on. So these are sort of the nice interconnection that we're doing, and I want to go back to some of these projects that we mentioned this morning, and all of them are great. But if you take, for instance, such as the LEO network, which is a good program, but if you take random photographs of things in the ocean in random places, you need something to tie them together to actually provide context to them. And the only way you can do that is continuous measurements in the same place over time with data that's actually scientifically valuable as well. So with the local interest in each community, we've had programs that look at, or we're implementing hopefully programs that look at fish gut content. Some are worried about that. If you go to Kaktovik, one of our communities, they have completely different concerns. And up in Kaktovik, we've been implementing, so we're trying to do bi-weekly, monthly CTDs, and into Kaktovik, that means we have to hike out on the landfast ice, drill holes in the ice, and do CTD measurements through the ice. These kind of measurements are very, very rare too in the science community, so the value of this is trifold, I would say. It's the easternmost community in the Arctic US, and there are programs I'm going to show you soon that exist from the Canadians that are studying the same type of concept in the Canadian archipelago and south of Alaska, and we're trying to tie them all together into a pearl necklace of community observations. So currently, in phase one of this, we have now Old Harbor, King Cove, St. Paul, and then it's a big, big gap, and then we have Kaktovik up to the north. We are working with NSF AON proposals to bridge some of those gaps, and as a comment, I think every time I go to a conference I hear about a new community project with a new acronym, and somehow I think at some point we're going to reach some saturation state where we probably need someone who has an umbrella organization and just even keep track of the acronyms. And I think there's a lot of science fatigue in some of these communities too. There's a lot of us coming, asking them for a lot of things, and they're not always seeing a big feedback. So that's sort of a middle of my talk comment that I just wanted to insert there. So there's a couple of other projects that we are collaborating with who's trying to bridge the gap between St. Paul and Kaktovik as we speak. So here's a very simple thing that we do. We started with a certain type of CTD that these kids are way smarter than we are, at least smarter than my grad students for most of the time. So these are very simple instruments. They are basically self-recording, and we now moved over to a different technology, and the reason we did that was because the Canadian programs south and north of us are using that, and we want to standardize the instruments and get the exact same sampling done. So we're now measuring fluorescence, salinity and temperature, and these are the best instruments basically on the market, so you can look at very small climate trends in this data from this instrument, and you don't have to worry about accuracy, precision, and so on and so forth. They have Wi-Fi, so we're working with RBR and Ocean Networks Canada to develop apps to make it much simpler for people to use them. Start, stop, download, forget kind of application, which makes it easier. So what kind of data do you get out of this? Here's an example here from Kodiak that I thought I'd show you. This is Gon Klo, who works in the school in Kodiak. He fixes all the plumbing in the town. He drives the school bus. He's the janitor of the high school. He's like one of these persons that you love to connect with because you want someone who's a doer. He's definitely a doer, and he's been going out every other week for the last 2 years doing CTD tests in the bay outside of the Old Harbor. And what you can see is some data set that we could never generate as scientists, say at UEF or at UW or where I used to work at Woods Hole. We would never be able to do this. But with Glenn's help, we now have this amazing time series of, you see spring stratification setting up. You have fall storms that de-stratify the ocean. You can look at the salinity. You can see these 5 to 10 meter thick freshwater pockets that come, and they enable the spring bloom to set up. I mean, this is just really fantastic data of the highest quality that's collected by local people. And this is ongoing, and we've developed a way where we can feed the data back to the communities in semi-real time. So it's pulled to a Dropbox, the Dropbox go to a server, does QA/QC, plots it up so the community observers get immediate gratification and look at their contribution online, and it's available for anyone to download immediately. So I think this is one way to do community observations, and I think the power of this particular program is that we're collecting really hard, best possible scientific data. And when we're now trying to move into the biological Rian, and if we can set that up, I think we get a bigger tie-in to say commercial fisheries and some of the concerns that go around, say Kodiak or wherever we are in this. So here's sort of what we're trying to do after. I'm sorry, we're going to miss the discussion today. We kind of didn't review program, but we're going down to Sitka and we're going to try to start up the last community, what we think for the C202 program for now, together with the tribes down there, the Sitka Science Center, and Reed Brewer, who's one of our alumni from UEF. And we're hoping to basically maintain these for decades and decades on end with continuous measurements and get these kind of GAC1 time series that I was showing you. Another cool thing that happens is you get this organic thing happening. So St. Paul got super fired up about doing this, and they've been doing it their longest since early 14. They got so excited, so they bought their own CTD, which is sort of now a $12,000 instrument. So it's a small investment by any standards, or a big investment. And then they gave their CTD to St. George, which is nearby, and they started up the thing, and they're now taking ownership of it, and there's no cost really for C202 other than managing the data. So it's this sort of, what we're hoping for is this organic growth of the program without us really having our fingers involved too much in this thing. If you look at the big scale picture, here's this Ring-Around Coastal Domain map again that I showed you in the beginning, and really what we're hoping is to link this to a Pan-Arctic concept. So south of C202 is the Mosquito Fleet concept. It's started up by Eddie Carmack in Canada at DFO, and they have a fleet of fishermen on small boats that are doing CTD measurements. We have C202, who we hope is going to cover with some partners most of Alaska, which is a big deal. It's a big area. And then north of C202 in the Canadian archipelago, Arctic archipelago, we have the Canadian Ranger Ocean Watch, which are Canadian rangers that are traversing on snow machines and on little skiffs in the summertime, and they're doing CTD measurements with the same instruments, with the same techniques, exactly as we are using in C202. So we already have something from Vancouver all the way to the lower part of the Canadian archipelago covered with community observations. And I visited some senators in Maine, and they were super excited about maybe starting up something similar with crab fishermen, so lobster fishermen in Maine, and sort of start to tie this whole thing up. And in July, Tula and I are visiting the Arctic Science Summit thing in Tromsø, and we're going to talk to I'm Swedish, so it'll be super easy to get them excited about this, and to start something similar on the Scandinavian side. So I think we're starting to see something that might grow into a Pan-Arctic community observing system, which will enable us to really get excited about looking at south to northward climate trends, for instance. So here's sort of where we are now. I took this picture the other day in Old Harbor, and that was the weather we had. It wasn't a shabby day. St. Paul is plugging away. Kaktovik, we're hoping to get a little bit more active, and we're in all these communities collecting continuous high-quality scientific data. 5 minutes remain. Thank you. So basically, we heard a couple of people talk about some challenges with this. I think for us, the big challenge has been that it's more time-consuming than we thought it would be. And the best communities, with best meaning the most active and communities that are really functioning for us, are the communities where we spend a lot of time in person, face-to-face, sit on our hands, talk very little, listen a lot, and interact with the high schools. And then once you interact with the high schools, all sorts of magic things happen, and that's been sort of key to us. The kids get excited, the parents hear about the kids being excited, and then they get supportive, and then it goes all the way up, and suddenly the community is sort of exploding, and a lot of doing these measurements for us. So not only because we're interested in the kids in education, but it's actually a key to getting the community to function for us. And again, I want to reiterate that there are some nice community projects out there, but if you collect random data in time and space, say a photo of a dead whale on the beach, that's good information, but if you're going to do science from that information, you need to collect other scientific variables that are in concert with those observations. Otherwise, it's going to be really hard to understand mechanisms and processes that are causing some change that the local community is observing. So thank you. We'll miss the discussion, but we'll be on a flight to Sitka, and you can call me. Maybe.
Can you dial in?
I can dial in, and here's the website address for C202. You can also go to MPRB's website. You should be able to reach it there, and my email and Tula's email, and I'll take some questions. Thank you.
Hey, thank you, Peter.
Great, nice to see the room filling back up.
That's good.
Do you have questions for Peter? We're going to lose him here this afternoon, so Julie?
I have a question for Peter. I'm really excited to see your guys' work. I too work in Old Harbor, as you know. I'm curious, you mentioned that the cost of managing the data. Can you give me an estimate of what that looks like?
Yeah, I mean, there's some...
Say for a sampling period, or 1 day, or...
Well, we try to give a little honorarium for our postal observers. And one reason is that, for instance, in Old Harbor, Glenn is taking his private boat and using gas to get out to this location. So we want to make sure he doesn't go on a minus budget just because he's such a nice guy. That's one small cost. Some communities opt not to take that cost because they say, we're doing this anyway through our environmental office in the native tribe, for instance, and they say, we'll just do it anyway. That's a small cost. The big thing that we spend a lot of money on, which probably shouldn't say this, but we charge other projects that are doing similar things, so it wouldn't hit this project, is to deal with the data flow.
Right, that's my specific
So,
question.
and we want to, the other problem is to make it as easy as possible for the local people, so they don't have to be a computer wizard or anything, but it's, so the best thing we're doing now is an automated drop to a Dropbox or Google Drive, and then we have scripts that our servers grab the data.
Like,
and
how much time do you guys have to spend to get that one CTD?
Now, almost zero. To start it up, it was a significant amount of programming and meetings and trial and error and all that good stuff. AOS is also helping us. I think we have an AOS person here who's going to talk for a while. I think that's more in the sort of archiving somewhere and doing that kind of thing. For that data flow, we're dealing with that ourselves at UVF. And for us, the important thing is whoever takes a measurement, that they immediately get to see the fruit of their labor on their community website, and they can see, oh, here's my data that I just collected. I think that's it.
I was curious, how do you deal with things like, I'm assuming you need to calibrate that CTD periodically? Do they just ship it off? And I mean, how do you deal with those kind of logistics?
We started in 14, so we just started to get into those troubles. These CTDs are, unless you do something silly with them, they're sort of good for about 2 years. So we're just now, we bought 1 or 2 more CTDs than we need, and we just hot swap them. And they get a new one, we take the old one, we send it off for factory coverage and get it back. And that's how we do that. If you had a gazillion communities, that would be a very big problem. With 3 to 5, it's manageable. Good question.
So yeah, I was wondering what, you said that you didn't want the community people to have to be computer whizzes, but what kind of computer training would be necessary for them to deal with their own?
Very little. If you can drag and drop a file, you're good.
Well, but what computer stuff are you making that I mean, what's behind that to make that possible? Is that something they could learn? The things that are behind that?
Yeah, I mean, we talked to some of the high schools, both here in Old Harbor and in Kodiak, in King Cove, that where the high school kids are more interested in the coding, like we saw the great presentations earlier today, and in that case, we're happy to give them access to that and actually have them help us develop and make it better. So there's the STEM techie side is there too. And I personally, my lab will run a lot of underwater robots, and we talked about maybe implementing that in some places where they can also do the programming or robotics and deploy and recover AUVs, for instance, for us. So the sky's the limit. If you have a community that's super gung-ho, and especially driven by high school kids, you can push it much further than these standardized measurements that are used.
So do you want only one community on Kodiak Island? involved in this?
We can, more is better.
Okay.
Yeah.
That was gonna be my
I
follow-up.
was thinking the same thing.
We see here, and especially Old Harbor really shines because I don't know where they started, they have an initiative, they've got some really strong partners, and they're doing amazing things. And then some of our other villages are struggling to match that, and it would be interesting if we could consider how we could share that. Like, have you ever considered mailing that, flying it to village
Yeah,
to
so
village?
Jeff
Like
Bechtal, who's the science teacher in Old Harbor, we gave a chit chat to the kids around Kodiak yesterday, where all these science classes were online on the video conferencing system at the same time, asking questions. And he, for instance, when we bought them the digital microscope, the other communities got super interested, so they actually went ahead and bought some themselves and started to implement that in their own classrooms. So that's sort of this organic spillover effect that we're hoping for, both on the high school side and on each participating community. Okay, thank you.
Great, thank you.
Just keep moving on through the presentations. We've got a great lineup for this afternoon. So next we have Chris Whitehead. He's with the Sitka Tribe of Alaska, Southeast Alaska Tribal Oceans Research. And he is going to be talking about the monitoring paralytic shellfish toxins to provide sustainable access to traditional resources.
Yeah.
Thank you. Chris, welcome.
Thank you.
Great, well, thank you. Yeah, my name is Chris Whitehead. I'm the Environmental Program Manager for the Sitka Tribe, also the Director of Southeast Alaska Tribal Ocean Research, which is a collaboration of 15, actually now 17 tribes in Southeast Alaska. And I'll kind of go into a little backstory about that because I think it has a lot of merit to the sessions we're talking about now with community monitoring. But we have a handful of projects, and the one I'm going to talk to you today about is really our initial project that started to look at PSP. So just some of our other programs we have an environmental lab that is linked to our PSP toxin analysis program. Someone mentioned acronyms, we have a lot of them too, just to have fun with it. But we have the Southeast Alaska Regional Ocean Acidification Monitoring Group, or CROM. There's a huge effort to spin that up right now, and I'm not going to get into all that, but if you're interested in talking about OA issues in Southeast and what we're doing, you can find me later today. We also have a sysbed mapping project in Southeast, looking at where these Alexandrian cysts settle out, mainly for the commercial industry, but also for subsistence use. So this is a great photo just to show if folks aren't aware of how toxins get transferred into humans. Does everybody know how that works? So I don't have to get into this? Nobody knows, really? Okay. So some phytoplankton create toxins. We'll go into which ones those are, but shellfish don't really care what they are. They're going to eat whatever's out there. And so the problem is that when we consume shellfish that have filtered out a lot of these toxins, that becomes a problem for us. Not only making you sick, but could be fatal. And we'll get into a little bit of this later. So really, these are the three species of phytoplankton that we're worried about in Alaska. But with warming waters and conditions, we could see this list getting a lot longer. And I'll start at the bottom just because I think everybody's familiar with shellfish poisoning. Julie's done a lot of good work here in Kodiak. It's not an Alaska problem, it's all over the place. It's actually first started in Alaska in 1799. It was one of those first kind of noticed by folks besides the native population. So it's been here for thousands and thousands of years, and people have worked with it. But it's produced by a species named Alexandrium. It creates saxitoxin. The other one we have is dinophysis. It creates ocodaic acid. There's some little tattoos I put on the table out there, and that was this species. It's really pretty under the scope. The last one we have is pseudonychia. It created that huge bloom in 2015 that shut down crab fisheries all up and down the west coast. That's amnesic shellfish poisoning, permanent short-term memory loss. So it could be a good thing depending on who you are. So really I wanted to talk about this partnership because if the Sitka tribe tried to go out and do this on its own, what I'm going to get into next, it really wouldn't have happened. It was really this common concern with the subsistence resources in Southeast. when I started in 2013 with the tribe, there was elders that came up to me and said, how can you help us with PSP? We want to dig clams. My past, I'm a shellfish biologist. I worked in Washington State for a long time, working with tribes, setting up programs similar to this, not only with biotoxins, but with gooey duck farms and a lot of shellfish resource management. And so I think timing was right. When I came up, I brought a lot of folks from from Washington State with me to help kind of build this program. But we reached out to the state is the first thing I did. With the state program, there really wasn't any funding there to do anything on the ground for us. There was a pilot program kind of in its last leg, I think, that Julie had worked on. But that was really the only kind of subsistence piece that the state had any kind of outreach for. So we looked to the other tribes. How can we utilize environmental programs in each of these villages? Because everybody's got these EPA IGAP programs going. That's really how it started. And so we'll get into how that works and what that looks like in a bit here. But we started with only 6 tribes that were really interested. And then once we started doing this for the last couple of years, we've now, like I said, have got 17 tribes participating. And we've kind of reached out of Southeast, and I'll get into that a little bit too. But just what the state puts up are these signs that don't ever come down. So there's times when there's toxins in the water that you should have a sign up, but there's also a lot of times where it's not, where you could be digging clams. And that's what we kind of wanted to address. So if you're not familiar with Southeast, it's just across the street out that way. But basically this is our village sites that we have, all the way up to Yakutat to the north, down to Prince of Wales Island in the south. A few other tribes that aren't on this map, we just kind of joined this last period here. So each of these communities monitors 1 to 4 beaches that the tribe designated as kind of their traditional area that they wanted to harvest at. So we'll get into what that monitoring looks like. That's just a photo from our last HAB workshop that we held last year. And I think I put some flyers out there as well. We have another one coming up in about 3 weeks that a few folks from here will be attending. So who regulates for PSP in Alaska? It's the DEC. I kind of mentioned that earlier, that the state program, their main focus is the commercial industry, so any of the gooey duck divers or the shellfish, oyster growers, all those samples get tested by the DEC lab. But that's kind of where their scope ends. They really don't have the funding or staff to do much more. Alaska's a big state and a lot to tackle, and so I think that's been brought up a couple times. The state, isn't doing something, and these other groups are starting to kind of pick up the slack. And that's really where our program comes in. The regulatory limit for PSP is 80 micrograms per 100 grams of shellfish tissue. So that's kind of the level that the FDA uses and the state uses to say is it safe or is it not safe for human consumption. So what about subsistence? I mean, that's really where our niche is. So we needed a program set up because there wasn't one, and that's really how this thing started snowballing. Those other projects I mentioned earlier were kind of afterthought. But really this was the key to starting this collaboration with all these tribes and different agencies. Just wanted to note too that Alaska is the only state that doesn't have a long-term monitoring program for PSP for subsistence, and the only state where people still die from PSP, mainly in Kodiak and in Southeast. So it's a good thing we're working together. So this is what our monitoring program looks like. We didn't create the wheel. We're using techniques that have been proven and QA'd down in Washington State. So basically every week the technician from environmental staff in these villages goes out and collects a phytoplankton sample, some other environmental factors like temperature, salinity, air temperature. Then they're taking a whole water sample and pouring that through a filtering system to get the cells onto a filter media. They're entering in their data directly into our database, hopefully. And then we're also looking at those cyst beds, which is that far picture there. That's actually not an every week thing. It's kind of once every few months we're doing that. But then every other week we're also collecting shellfish samples from each of our sites. So it's really important that we have kind of completed this circle. We're looking at phytoplankton, looking for those species that are producing the toxins, and we're testing the shellfish. So all that, most of that gets done within the villages. They do all the analysis on the microscopy. But the shellfish and the filters get sent to our lab in Sitka, and so we'll get to that here in a sec. So when you join our Cool Club, you get all kinds of neat things. So this is all funded through a bunch of different sources, but EPA IGAP is kind of the main funder for each of these individual tribes to work on this project. So you get a digital microscope with a camera. It's an iPad tablet on the top, so it makes it really, really easy to share information. It's all Wi-Fi connected, so if somebody in Yakutat is looking on their scope and they don't know what something is, they can IM me on their scope, and I can look at it right away on my computer and tell them what it is. So it really makes the interaction between the communities kind of real time for the microscopy. And then they get some other tools to measure those other pieces that I mentioned earlier. And then we host these trainings in Sitka once a year. So like I said, the next one is in a couple weeks here. And so we fly everybody in, bring folks up from Washington, we bring a lot of our other project collaborators in to do the trainings. And we get people trained on how to collect the samples, do the microscopy, do the data entry, those types of things. And there's also videos and a sampling manual that's on our website. So if there's a lot of staff turnover, which there is in tribal world, sometimes it's a matter of weeks that we have a new person that comes in. Not really in Sitka, but in these other outlying communities. So there's tools online to get someone right back up and running, because the key to this program is consistency. So every week this is happening. So we need to make sure we follow that. So then there's our lab. So in the beginning of this, we wanted the DEC to run our shellfish samples for us. And the problem was that, like I mentioned earlier, their real focus is the commercial industry. So turnaround time for any samples that aren't related to that commercial industry is really lagged, sometimes 8 to 12 weeks. So it really doesn't do us any good to have that data when we're trying to do some real-time monitoring to keep people safe. So we got a whole another gob of funding to build this lab. So the lab is mainly used for the tribes to set up these shellfish management plans and utilize these beaches that they're monitoring to have their own little subsistence fishery on. And the key to that is really that quick turnaround. So we do sometimes same day data turnaround, or sometimes 48 hours depending on the workload, but no more than that. And that's important because these toxins change really quickly. So something 10 weeks later, is completely different than what's happening right now. So that was really the key, is to have that turnaround. So we use the receptor binding assay to measure saxitoxin and all the other congeners, but it's similar to the mouse bioassay in a sense that it's a total toxicity test. PSTs there's somewhat 32 somewhat congeners in saxitoxin. And so being able to capture all those is really important for public health. So the mouse bioassay, which is an assay that was put together in the early 50s, where they basically injected a mouse with a slurry of the extract from the toxins and timing it until it dies, is kind of the standard way that regulatory labs use for public health. This is a newer method that most of those labs that are doing the mouse are trying to move towards. We're basically zooming in on the receptor site in that mouse biology, which I'll get to here in a sec. But it's good. It's got a lot lower detection rate of 6.4 micrograms. The mouse is about 38, so we can kind of drill in a little closer. It has a really high throughput, so you can run a lot of samples at once. So it makes it really fast and efficient for doing public health screening. This is just a diagram of the lipid layer, how saxitoxin works. It binds to the sodium channel. So that's the problem with PSP, is when that happens and your mind is telling your body to move, those signals can't get past through your sodium channel. So if it's your brain telling your lungs to breathe and that's not happening, and that's where the fatalities happen. So the RBA, or the receptor binding assay, is really just kind of zoomed in on this, trying to look at this picture right here versus the whole mouse biology. Does that make sense? Nobody's nodding. That's good. Okay. The other assay, we run a couple other ones, but the other main one is for domoic acid, which we use an ELISA-based. Domoic acid has one congener, so it's easy for this assay to work really well. We're also in the process of setting up a HPLC to to also be a backup for our domoic acid test. So then we have all this cool data that is worth something and people want to see. So it all gets posted to our website. We're in the process of redoing a lot of this data management with Axiom and AUS. I'll get to that in a bit here, but right now it's just kind of in a list form and a map form. So each of the villages that have our program have X amount of beaches that they're monitoring. So you can go and click on each site and see when the last sample was taken, what the results were. We use a easy stoplight method, so it's not a lot of information to take in. Is it red? Is it yellow? Is it green? If it's green, then it's good to go. If it's yellow, there could be advisories for certain species. Toxins get picked up and decorated differently in each species, and we see butter clams can hold on to for up to 2 years. So we might have a site that's yellow because the other little necks and cockles were way below that regulatory limit, but the butter clams could be way above, so we want to make sure that information is expressed. So there's also a map version. If you scroll down on our site, this is just screenshots. So you can zoom into an area that you're interested in. You can see we also have sites in Ketchikan Bay and here in Kodiak. The Shunak tribe and a handful of other tribes are starting to get on board with this program, and we're trying to reach out to folks here. That's why I'm here, to kind of gather some folks together and see if they want to be part of this and get some real-time data for their tribal citizens. So if you zoomed in on one of these sites and went in even closer, you could click on one of the bubbles and it would tell you some basic information, the location, the site name, the date it was last sampled, and any types of notes. So if there's an advisory set up for that or whatnot. So we do a lot of outreach and community events as well. We work a lot in the schools. I think that's been brought up a handful of times. We work with both high schools and Sitka, and it's a really good thing for us. We have interns. We have 5 interns every week that come in and are learning how to do ELISA. They're learning how to collect phytoplankton, and they're bringing that back to their school and working in their classrooms. And then we also have a Facebook page that all of our data updates are posted to. So if you're Facebook savvy, that's an easy way to see a lot of our information that we're working on. And then our website as well. So this was kind of what I wanted to get to. How do you participate in this? If you're a tribal community and you have EPA funds through your IGAP program, that's probably the easiest way. What we can do is give you work plans and training and supply lists of what to buy. The cost, it's really the first year starting up, is there's some substantial cost. It's about $8,500 in supplies. That's your microscope, your net, all the bells and whistles to go along with doing the weekly work. And then it's about $2,800 a year in your analysis at our lab. And that'll cover anything from 50 to 60 samples depending on what you're sending in. And then about every year, you're probably spending only a couple $100 besides your analysis cost, and your 1 day a week for your staff time. So not a very big cost to provide a lot of information to a lot of people that want to participate. So other partners that we have besides the tribes, we work really closely with NOAA, both programs in Seattle and in Charleston. Charleston is the one who kind of brought up the receptor binding assay and helped train us. And then the Northwest Fisheries Science Center is the phytoplankton side of things. They're the ones who train most folks in Washington on how to do those collections. And then we work with UAF, and we work with SARTFA, the gooey duck industry. Washington State Department of Health, we have a lot of programs or sharing data with those folks and doing a lot of work to get the receptor binding assay through a couple more hoops for the industry. And then we work with DEC as well. That relationship has gotten a lot stronger. It used to not be there at all. In fact, in the beginning, it was said that we couldn't do what we're doing. And that is just fuel to the fire, at least for me. And so we've come full circle with them, and they're one of our main partners in the project. We work a lot with CDC for equipment. We put a lot of our stuff through them. And then Ketchikan Bay Research Reserve as well. And I do want to mention, and Julie might mention as well in her talk, but the Alaska HAB Network is this new thing that there's a handful of folks in Alaska working on HABs. Julie in Kodiak, our work down in Southeast, and then there's a whole handful of others. So we finally all got together and decided that it's a good thing if we all talked regularly. So we've started this Alaska Hab Network, or AHAB. And so you'll be hearing more about that in probably the next six to 8 months as things kind of get legs under them. So a lot of people ask, like, how do you fund these types of programs? You know, a lot of times people talk about community-based monitoring as volunteer. There's no volunteers in our program right now. It's all paid staff through these villages. There's the volunteer pieces that we do have are some concerned citizens in Sitka that are interested, and they go out and collect stuff and bring it in and we can look at it. But really it comes down to funding. You need money to do these projects. It's why the state doesn't do it. They don't have any money. And so we've pooled together money from all kinds of agencies, it's close to $2.5 million so far to do this. And so it comes from different pots, EPA, BIA, ANA, all the A's are involved at some level. So yeah, so it's just, and with not knowing what the funding's gonna be like in the near future, it's really scary for us, so. Anyway, hopefully I finished right on time, but I do have probably a second for questions.
Yes, you do. We have a few minutes for questions. Thank you, Chris.
Yeah, thank you. That was a really great presentation. I have a question for you. I saw your handout out there, and I walked in yesterday and had just taken a look under the microscope and saw these
Pizza
algae
Steve's.
that you have in the right picture, and I have not seen them in association with harmful algal blooms before.
They're not,
Is
no,
that-
it's just
is
a
that
cool
different
picture.
examples?
No, it's just a picture, yeah, it's not, that isn't a HAB species.
Okay, that's what I thought.
Yeah.
Thank you.
Did you have a question?
Yeah, what's happening now to the historical data, basically, the time series?
So we started really collecting in 2014. Depending on the site, you know, there's ups and downs. In the springtime, we usually see a big bloom of Alexandrium, if that's where all we're really looking at. The other ones we look at and we record, but really the one that's causing all the problems is PSP. And so we look to see what the Alexandrium is doing. But usually in the springtime, right now, really, April, May is when we saw the last couple of years, at least in Southeast, blooms, and I'm sure Julie can speak to what happens here. And then we also see another bloom, usually in the late summer, early fall. When the temperatures get too warm, Alexandrium doesn't really do too well. So there's kind of a window that they do really well. But what I showed in that first picture, in the wintertime, they'll go dormant. Those cysts will settle out in the sediment. And then in the spring, when the conditions are right, they'll come back up and be vegetative cells. So you really got to be able to know where those spots are to kind of predict where these events will happen.
I guess are those the historical sample results, are they like being made available?
Yeah, so eventually, hopefully within the next couple of weeks, we're hoping, and someone from Axiom is here and they might be able to speak to it, but oh, that's true. Well, good thing we're talking. Yeah. Yeah, so as soon as you know the data set and the mapping tool that you guys are working on is available, then a lot of that old data can be incorporated. And then it'll be easy to see. Because right now it's not very easy to see if you go onto our other database where our Fido data lives. You can look at your own data, but unless you have access to everybody else's, which we do, but it's still hard to look at versus what you guys do, I think is great. And hopefully you can share a little bit about that later.
One more, too. How do you feel about the acronym AHAB?
Hey, you know, AHAB was an old acronym. There was a monitoring group in Southeast through the university that started up in early 2000s. I can't remember exactly when it was. The co-director of SART for the Kodiak industry, she used to do it when she was at the university, Kate Sullivan. And her program was called AHAB, Alaska Harmful Algal Bloom. And so we kind of resurrected it, and it sounds way better than CTOR or any of the other ones. So, anybody else?
I'm curious about your claim of total toxicity, because I see with this receptor binding assay, you could have potentially a very large amount of a weak congenitor that would bind real rapidly, show a very large pulse, but then would be weak. It would just drop away from the receptors. So real life survival would be an entirely different thing. How do you get to the claim of total toxicity here?
So there's a kind of a handshake that happens with each of those, like being weak versus strong. So the way the receptor binding assay works is it's a competition between a tritiated saxitoxin and your normal saxitoxin, and they're competing for that handshake in this receptor site. This isn't going to answer your question at all, and I would encourage you to, I can give you some folks that can answer it really well, but it is a proven, it does work for total toxicity. That doesn't answer your question.
Great, well, thank you very much, Chris. This is great. I see a lot of connections being made through this symposium. So, okay, next up we have Dr. Bob Foyle with the National Marine Fisheries Service right here on Kodiak Island. He's our lab over across the way. And his topic will be monitoring ocean acidification and the sustainability of the crab fisheries in Alaska. So, welcome, Bob. Thanks for being here.
Thanks, Teresa. So as Teresa mentioned, I'm going to speak about ocean acidification and crab. And I have more in my title than I could cover in hours. But what I'm going to start with is just a little bit of the experimental results that we have come up with at the Kodiak laboratory here. That's our main focus, is physiological work. But then I'm going to take it more into the monitoring program that's going on throughout the Gulf of Alaska, and then also more at home that we're developing in more recent years. I did want to acknowledge I've got lots of co-authors on here. The work I'm about to show represents multiple agencies, multiple researchers throughout the Gulf of Alaska and the North Pacific. So just to begin with, just a two-slide primer of ocean acidification. We know that carbon dioxide is increasing in the atmosphere. We've got data from the Mauna Loa site at about 11,000 feet, where they've been collecting atmospheric gas information since the 1950s. That shows consistent increase. This is just 2013 to current, but a consistent increase in the amount of carbon dioxide. We went past 400 parts per million this past year. The variability here is the annual variability in CO2. The planet respires, and releasing carbon dioxide, and the planet, when the phytoplankton blooms occur, take up the carbon dioxide. And you'll see a little bit about that on a more local scale here. For Alaska, well, for the planet, 22 tons of carbon dioxide every day gets produced. About a third of that is absorbed by the ocean. That's the part that we're concerned about with ocean acidification. For Alaska, Alaskan waters are naturally high in carbon dioxide. So there's a two-part effect. One is the natural processes, and one is this anthropogenic CO2 that we're seeing. And I'll show you some of those specific results. So ocean acidification, why is it important? The carbon dioxide goes down into the water. Carbon dioxide combines with water molecules and carbonate to become bicarbonate. Not quite as simple as that, but for the most part, when your carbon dioxide enters the water, it grabs up an ion of carbonate. So it's removing carbonate from the water. That then is removing that carbonate from use for shell-building organisms. So the carbonate and the calcium combine to build the shell. If that carbonate's not available because it's getting bound up with carbon dioxide, it's no longer available for that shell. In the process, it's releasing hydrogen ions. So it's decreasing the pH. So it's a two-part effect for organisms. One is a decrease in pH. One is the availability of that carbonate ion for a shell-building animal. So you may see this, I'm just going to touch on it. We talk about omega, or saturation state. This is the availability of carbonate in the water column. If it's greater than 1, there's carbonate available, readily available for an organism to build its shell. If it's less than 1, that carbonate is harder to come by for an organism to build its shell. So at a omega value of less than 1, we say that it is undersaturated. And an organism, a shell, is likely to dissolve without some biological activity to help keep that shell intact. So again, I'm just touching on the biology today, but there have been many studies, hundreds of studies have been done to look at the effects of ocean acidification worldwide. Some of the negative responses have been changes in respiration rate, changes in aerobic metabolism, greater energy and shell maintenance. All of this to say it's a physiological perturbation. So the animals that are in acidified conditions, in corrosive waters, are physiologically adapting to another stressor. It's like working in or living in a temperature that's outside your range. It's a physiological stressor. So we're seeing changes in energy. And I'll show you some local results where we're seeing the same thing. So a little bit more about the chemistry and why it's important to Alaska. So this slide shows a transect from Hawaii to Chiricahua Island, just south of Kodiak here. And what you're seeing here is this is depth, and this is the amount of carbon dioxide in the water column. So you can see at mid-latitudes and central latitudes in the surface waters, there's plenty of carbon dioxide in the water column. As you get closer to Kodiak, you can see that that starts to shallow. That dissolution layer shallows as you get closer to Kodiak. Colder waters in Alaska hold more carbon dioxide. They found during that survey that it's upwards of 100 to 200 meters. So what that means is that any organism, shell-building organisms below that depth in Alaskan waters are already physiologically dealing with the stressor of a lack of carbonate availability. So predictions for the future, and these are based on models of carbon dioxide in the atmosphere, carbon dioxide going into the water column. What you can see on the top here, this is 2012. 2012, you can see that everything's in the red. So this, except up in the Arctic. You can see that that means it's above that 1. It's saturated. So in the surface waters, not a lot of concern right now as to whether or not there's enough carbonate availability. As you get to 2050, 2021, you can see the reduction in the amount of carbonate that's available in those surface waters and the predictions that will be undersaturated in our surface waters by the year 2100. So that's a potential that the shell-building organisms are going to have to deal with. So how does ocean acidification impact animals? This is just a quick schematic here, purposefully using fish to show that as the carbon dioxide goes into the water, first of all, there's direct effects. The direct effects of carbon dioxide increase may be the pH effect on the ability of a polyp or a cod to grow or to have gas exchange across gill membranes. It may be carbonate availability for a crab to build its shell directly. Secondary effects include behavioral or sensory effects. There's been a number of studies that have shown that some species of fish lose the ability, the olfactory ability to find prey with lower pH. That's going to be a problem, obviously. Food web effects, indirect food web effects. Pteropods are known to be severely affected by acidification. They're also one of the most important prey items for pink salmon. So that's an indirect food web effect. Cumulative effects, ecosystem effects, building on entire ecosystems where you lose a particular organism, ocean acidification may affect the entire ecosystem. So lots of different layers to consider different animals. So next I'm going to show some results based on some laboratory experiments, and this is really our focus of what we do both at the Newport Laboratory in Oregon as well as the Kodiak Laboratory here over on Deer Island. Some initial work on northern rock sole has found that they are sensitive to increases in CO2. They have found not much effect at the hatch of the eggs stage, but reduced growth and higher mortality in high CO2 levels. So those studies are just coming out right now, but that's northern rock sole. Walleye pollock, however, there's been no results that have suggested that ocean acidification is an issue for walleye pollock. And again, remembering that this is just physiological effects in the laboratory. So they're moving on right now to look and see whether or not there's any behavioral effects of acidification on pollock and cod in particular. Tanner crab. We have found a substantial effect of acidification in tanner crab and red king crab and many of the crab species. We could give talk for hours on the effects that we have found in the laboratory here in Kodiak. We found that they're very effective, especially at the younger life stages. When embryos are exposed to acidified water, that negatively affects all the rest of the life stages to the point where we're seeing substantial mortality at the larval stage, substantial mortality at the juvenile stage. And at the end, again, it's an energetic trade-off. The animal is trying to figure out how to separate energy that goes to shell formation or immunology or reproduction versus dealing with the energy required to build that shell or deal with this lower pH. Some initial results that we have found with the laboratory experiments where we've taken the data and put them in population dynamics models. These are thresholds we've come up with as to what the population level effects of acidification might be. The mortality we've seen in the laboratory scaled up suggests that for tanner crab, once the Bering Sea reaches a pH of roughly 7.7, 7.8, you've got about 20 years before you see a substantial decrease in recruitment. A substantial decrease, obviously, then in catch and profits, which has the potential to affect Alaskan welfare loss in Alaskan houses by $500 million to $1 billion. This is an extreme. This is a worst possible scenario based on our laboratory experiments and considering no acclimation of the organism. But this is important that we take this information to communities to explain the potential for where we're going or where ocean acidification might take us relative to our commercial fisheries. So all of this to say, what should we be doing? Notice my number one item here is monitor ocean pH. That's where I'm going to take the rest of the talk. There's a number of efforts going on to look at ocean pH and ocean carbonate system. It's not just pH, as I showed you at the beginning. So there's a number of moorings in different locations or have been in different locations throughout Alaska. This is some of the data on the carbon dioxide throughout a year from 2011 to 2016. And what you can see is it's highly variable. The complexity of ocean acidification relative to other parameters, ocean parameters, is very important for us to monitor. So in the winter months, you've got high carbon dioxide. In the spring and summer months, that carbon dioxide is drawn down. Phytoplankton blooms take up that carbon dioxide, and then you see it increase again towards the end of the year. This is atmospheric CO2. So you can see the variability in atmospheric, you can see the intra-annual variability that we're experiencing. And again, this is only from 2011 to 13, so we need a longer time trend in order to see whether or not we're seeing that increase in CO2 on an annual average scale. At any one particular time of the year, you can't go out necessarily and measure this change unless you have something from previous years to relate it to. So what else? What other kind of work is being done? This is NOAA's Ocean Acidification Program funding from 2015 to 17. We had a survey a few years ago looking at multiple locations in the Gulf, large vessels collecting carbonate parameters as well as other ocean chemistry as well as ocean biology at the same time. We'll be doing another one of these surveys in 2019. There's a number of studies that have been done, single process studies where they've taken automated vehicles to collect the parameters that we're interested in, mostly the chemistry. Right now we're trying to overlay those chemistry data with the biological data to get them collected at the same time. You've got the moorings I mentioned on the GAC1 line that Russ Hopcroft mentioned yesterday. There's the M2 mooring, and then we had in Kodiak a mooring for about a year and a half that was collecting data on carbonate. Some of the data is being collected in these different instruments, and we talk about monitoring and things that we can do to support science and technology. There's a number of tools being used right now, being outfitted with sensors. The sensors are getting better, and we're having a hard time with the sensors because it's difficult to measure the different parameters in the carbonate system. But these different tools have been used, automated tools, to collect data throughout the Gulf of Alaska and Bering Sea, and it's only going to get better. Obviously, there's funding issues associated with that, but the technology is catching up with our need. So why monitor? Some of the studies, these are the data from the Nearshore survey, we need to monitor because of the variability. Russ Hopcroft showed the interannual variability in the Gulf of Alaska yesterday. The seasonal variability. This is just a snapshot in time of that survey which occurred in the summer, where you can see the variability in temperature with different warm versus cold areas. pH, you have a lower pH down to 7.8, 7.9 in the surface waters already, and the offshore waters, and a higher pH in the nearshore waters at this time of the year. Salinity changes, and this is the amount of carbon dioxide in the water as well. So you can see it increases and decreases closer to shore. There's that interannual variability, that seasonal variability in the background. These two, the complexity of the carbonate system that we have to understand in order to determine whether or not this is truly increasing as a result of anthropogenic CO2. So this is just some of the data from the two moorings, one at the GAC line, one at the Kodiak line. You can see the seasonal variability in carbon dioxide in the water. Kodiak, you can see that the peaks of carbon dioxide in 14, 15, and 16 are higher. Scale at 500 here versus around 400 and the GAC line, showing that there's also spatial variability in these chemistry parameters. So, what can we do about it? This is the monitoring piece. There's a number of examples. We just heard a couple of fantastic examples about how ocean chemistry, ocean biology is being monitored in various areas. These are a couple of examples specific to the carbonate data that's being collected. It's being done in some cases along with these other parameters that we heard in previous presentations. This shows just a single slide from the Hawkeye Institute in British Columbia, where they've got data being collected on the local ferry system. They've got data being collected at single locations, moorings, as well as the citizen science piece, where they have people collecting data and passing the information back to the laboratories for monitoring, as we heard Peter talk about as well. This is an example of one of the instruments that's being deployed at these various locations that can adequately and accurately measure parameters in the carbonate system and provide data on a regular basis. A similar system exists in Seward at the Aleutian Pride Shellfish Hatchery. They're taking these data and then they're augmenting them with single samples, which is more the citizen science part, throughout Prince William Sound, Ketchimack Bay. Those samples are collected on a less regular basis to combine with the data being collected in Seward. So what's happening in Kodiak? This shows some of the sites throughout the lower 48, Canada and Alaska. You can see not a lot of these monitoring sites in Alaska relative to what's going on in the lower 48. This little symbol here represents a more considered effort where data is being collected. These are the moorings that I mentioned. This just shows some of the data being collected in Ketchikan with this system that's in Ketchikan. I believe Sitka's got one, Juneau's building one, and Seward's got one. The type of data being collected: alkalinity, carbon dioxide, pH, salinity, water temperature, basic parameters important for ocean chemistry and carbonate. What are our goals in Kodiak? Right now, we're building one of these systems in Kodiak. It'll be up and running by the end of June, beginning of July. So we're pretty excited about that. What that allows us to do is establish that baseline of consistent monitoring at the NOAA laboratory here, and then start building on that to collect data throughout the archipelago. We currently have temperature monitoring going on at 5 or 6 different sites throughout the archipelago that have been going on for a number of years with just real basic loggers. The goal will be to expand on that, similar to what's occurring in Southeast Alaska, similar to what's occurring with these other programs, to feed data on a regular basis. So right now, the number of stakeholders have gathered to talk about how we do this, to talk about what the risk is to the Kodiak archipelago. Why measure on the east side and the west side of Kodiak? Very different oceanography on the east side and west side. The effects of acidification are very different. You've got a freshwater-driven system in Shelikof versus a potentially upwelling system driven on the west side of Kodiak Island. There's educational opportunities. We heard a great presentation this morning. We've been working with that group to define how we incorporate some of these measurements into student programs so that they can help measure the data, maybe even help collect and store the data. Community-based collections, there's an opportunity for that. There's a lot of interest in the Kodiak archipelago. That's why we have this whole session. So we're trying to tap into that and figure out a way to collect the data that allows us to use it scientifically, that's done in an efficient and accurate enough manner that it's consistently usable and goes beyond just our local interest. establishing baseline, leveraging agency research, that's been the hard part. How do we keep this going 5 years from now? It's great to get a teacher enthused for a handful of years, but if you're not doing it 10 years from now, it's not monitoring. So how do we maintain that longer term monitoring and the funding? We've heard from every one of the presentations that funding is critical. So what our goal has been is to build this instrumentation into our research program and then come up with methods that are easy for folks to collect information and send back to us, whether it's with a low-cost instrument or whether they're taking small bottles and taking water samples, capping them, and sending them back to us on the mail plane from the archipelago, so we can run them on the instrument in Kodiak. And then lastly, just detecting the variability around the island that I mentioned. So last slide here, just a plug for the Alaska Ocean Acidification Network. This is a network that's been going on for about 1.5 years, maybe 2 years now. The goal of the network is to bring together the researchers, the stakeholders, the public, the fishermen, anyone interested in ocean acidification in the state of Alaska. It's a fantastic website. It's opened up opportunities for us to talk throughout the state about ocean acidification. We're talking about citizen science. We're talking about the interest that we've got in various coastal locations in collecting these data. So I encourage you to go to this website if you're at all interested in some of this work. And again, lots of folks have been involved in the data that I just showed you from many agencies.
Thank you, Bob. Thank you. We have time for one question. We're going to kind of clip along here, and then we have a community discussion this afternoon as well from 4 to 5.
I have a quick one. As you know, I'm a physical oceanographer, so chemistry is like I'm an idiot in your world. You just explain, I've heard these talks so many times, and you talk about the sensitivity of shellfish, crabs, blah, blah, blah. And you do these experiments where you sort of abruptly change the CO2 concentration. Isn't there a natural adaptation over like the last 100 years for this gradually increasing CO2 that is also occurring that is hard to replicate in the lab?
Absolutely. Obviously, I can't replicate a 100-year change in the laboratory, but it's happening much faster rate than 100 years. The changes and the expectations of going from a pH of 8.2 to 7.8 or even down to 7.5 as an average baseline in the next 50 to 100 years is an immense change compared to what's happened over the last 100, 200 years. So what we have been able to do, we've run the experiments where it's a quick change to see whether or not there was effect. We've run experiments at the laboratory across the bridge there that have lasted for 2 to 3 years, where we're taking multiple generations of crab and raising them through various life history stages. Right now we're running an experiment where we've got diurnal and seasonal variability occurring in the background as well to try and tease some of this out. So absolutely, the initial results are the worst case scenario, no acclimation. From there, we're looking at genetics, we're looking at physiology. So with the genetic work, we're already seeing changes in protein expression for cuticle formation in crab. So you're seeing that genetic response even in animals that are getting slowly adapted to changes in pH over time over a 2 to 3 year scale.
Thank you, Bob.
Yep.
That's great. Okay, we'll keep rolling along here. Next, we're going to have Julie Matliela with the University of Alaska Fairbanks, and Julie's presentation is entitled Paralytic Shellfish Poisoning and Community Involvement, Working Towards Safe Shellfish Harvest on Kodiak Island. Thanks, Julie.
Well, thank you, everyone. This is a super exciting session for me, and there's so many amazing projects going on in our community, and it's super fun to be here. I'm going to just give a short recap of some of the work that I've been doing here, and luckily Chris Whitehead spoke before me, and he covered all the details of PSP. He mentioned the new forming network, the Alaska Harmful Algal Bloom Network, that pretty much all the major players in our state are part of, and we're coming together to share our information and better communicate and just continue to build the information for our state. And it's by doing some of these statewide comparisons that we're starting to see some trends. We really are lacking data overall in the state and in Kodiak. So I'll share what I've been working with them the last couple of years. Chris covered this, and I think our community knows this pretty well. The organism that produces the toxin is the Alexandrium. It's the phytoplankton up in the left here. It produces the toxin. It's a naturally occurring toxin. It's a byproduct of the metabolism of the Alexandrium. The shellfish consume the algae, and the toxins are passed into the shellfish and up the food chain. Last June, the very end of May, somebody became ill in our community and almost died. So we hit almost record levels of PSP toxins here at the end of May last year. And after the initial report of illness related to the butterclam consumption, about a week later, some folks were reporting experiencing toxin sensation, the feeling of the toxins from eating snails. So we see the toxins moving up through the food chain. We often just hang on the shellfish component, but we can experience PSP illness through consumption of bivalve, snails, and in the case of crab, and the gut content. So I do a lot of education and outreach in our community. I obviously missed that one. It's always been hard to stay up and ahead of the game with this, especially with lack of funding. I don't have consistent sites that we monitor, and always room for improvement, which is one of the reasons I'm really excited about this particular session and talking to other researchers, and that we've got these other programs going on, and I'm looking for a way to can we tie it all together and all leverage each other's resources and continue to do the good work that we do. So Kodiak is known for some of the highest toxins in the state. We do have toxins throughout the Gulf of Alaska into the Bering Sea. And as Terry Johnson showed the slide yesterday, the more we look, the more we're finding the toxins pretty much wherever we look, up and even into the Arctic. So it is a problem statewide. Kodiak has traditionally reported some of the highest levels of toxins. We had a death in 1994 here, and that shows up on this chart here. The blue mussels were recorded at over 20,000 micrograms of toxin. The regulatory level is 80. Since this publication in 2012, we have seen even higher levels in other areas of our state. So I guess we lost our record holding place here, but we do have some of the highest levels and consistent levels as well. We also have some of the highest numbers of illnesses in the state, as Chris mentioned as well. Kodiak is often referred to as one of the locations where we do see PSP illness. I think it's about a third of the cases of PSP come from the Kodiak region. This is because we have a lot of people subsisting on the resources. My colleague, Ray Rolland, he's a professor emeritus now with Alaska Sea Grant, and I've collected information over the years working with him, and this is a clip of some of his overall, his information that he shares during his presentations. And I wanted to start to qualify this because I've used his work as a guiding factor in mine. I was just looking at this today thinking, I wouldn't say that there's an overall lack of concern from the public. In fact, I think it's quite the opposite. It's not exactly a lack of concern. It's that people want and need, and it's important culturally and socially to subsist on shellfish. It's an important component of our community. So I don't know if it's a lack of concern. Everyone I speak with, when I go out sampling and I meet people on the beach that are harvesting, not everybody, but most people know of PSP, and they're still choosing to do it. At least those are the folks that I see on the beach. I don't think I've ever run into somebody who doesn't know what they're doing on the beach. They might have these different rules and these rules that they're playing by, but people think they have the answers and they want to continue. Now I do see people in town that don't know about PSP. I run into folks a lot that don't know a lot about it. So I do a lot of community education and I'm working in the schools. Another thing I wanted to call out that, Ray, a lot of us say that there's a lot of myths involved around PSP. And there's a lot of different understandings or thought processes around this, but some of the myths hold some merit, which makes it even harder to talk and educate with the public. There is no beach testing, as Chris pointed out, but there are new and successful efforts being developed. So again, Chris mentioned this. This is a problem for our subsistence and recreational shellfish harvesters. There is no state funding to do this, but we do have a very strong commercial shellfish toxin testing program in place. So it really just affects our personally harvesting harvesters. Yeah, and as Chris mentioned too, if somebody gets sick nationwide, our national partners look to Alaska. They know that it's the sickness here in Alaska. So this is the question that I get almost every day, or at least once a week. Can I eat the shellfish? I tell them no, that they can't eat the shellfish. Look at the data that I've just collected for them, that it's above regulatory level, and that don't eat the shellfish. And then they say, but I am eating the shellfish. I already ate this shellfish. I ate this shellfish that I gave you to test, and I'm fine, and I already ate it. So this is one of the complexities that I face on a daily basis. So I've been primarily working towards responsive and reduced cost testing mechanisms or monitoring. I came to Kodiak in 1999 to do my graduate work through UAF, and I focused on nucleotide probes and probe formats to detect the algae in the water as an early warning detection mechanism, similar to what Chris was doing with his plankton toes. A lot of work and effort went into that. There's still a lot of benefit to doing water measurements. There's not a 1-to-1 ratio. When you find X number of cells in the water, you're not going to have X amount of toxin. So I have really retracted my efforts into actually doing the toxin monitoring. I love the water monitoring, and I would love to one day build it into our program. But for me, you still need to test the shellfish. You can test the water, and it can give you some early signals, and Chris is developing a good protocol, and there is protocol around the state. But for me, right now, we're focusing on the actual shellfish. Brian Hamilton's in the audience here. He's worked for a number of years back with the Gillette test. It's now called the Scotia Rapid test. It's an antibody-based test, and it's up here in the white little pregnancy test strip. It's a very sensitive test. Gillette company came to Kodiak in 2000. A lot of our community members have seen this test, and I continue to use it as an educational tool in the community because it's something that the kids can do. It's something that gives you pretty immediate results. And as I work with our community, I see that this test is showing, I haven't yet run a Scotia test that's not positive for PSP. So is it useful for our community? So far, it hasn't been, in my eyes, useful. It's also very sensitive. It records below the regulatory level. So that's tricky too when you're working at or slightly below the regulatory level and it's telling you that there's toxins, do not eat it. So we always go through that messaging. It is a useful test in other areas where toxins go low enough or to zero. So in some parts of our country, this test is very useful. In Kodiak in particular, the more I work with it, it's a great tool. It hasn't shown to be an effective tool for Kodiak. When I started a couple of years ago, I worked with Brian on the Abraxas ELISA. This is a laboratory-based test, antibody-based test. We learned a lot working with this test. In fact, it's really spun off some new direction of research of interest. But I've since moved on and I'm working with some folks on the electrochemical test, a new EC test. So very quickly, show you some data from the 1990-2001 period, and this data is part of the work I collected as my research in 99, 2000. And this 2000 peak, if I just try that pointer. This 2000 peak is really representative of this dinoflagellate, and Chris mentioned this as well. We see this typical spike in the early or late spring, We see it peak in early summer, drops down into in the middle of summer, and then comes kind of back up. And we see this bump, and it's a nice clean bump up. It's not consistent, but that's a really pretty example. Also, as you see in this graph, I sampled at multiple locations throughout the study period, and while the timing is pretty close in each of these beaches, there's a spatial variability. The toxin level concentrations differed between sites. So testing one beach and saying that it's okay to eat from another is not going to work. So it's very beach specific. The need to test each beach is very, very important. I've been working with the communities of Old Harbor and Helsinki, and I've started working with them through the pilot study that Chris mentioned as well. It was a 3-year study period. We collected data for about 2.5 years. Helsinki both communities started in January 13, and as you can see, Helsinki, in the first part of the study period, Helsinki hovered at or slightly below the regulatory level of 80, and in the second part of the study period, Helsinki popped above 80 and stayed. Even during winter months, they didn't clear. So what I'm seeing here is this trend of background toxins pretty much at the regulatory level throughout the seasons. Old Harbor never cleared below 80. We also saw some moderate bumps up to 400 micrograms of toxin. That's not super, super high. It causes alarm, it causes me concern, but it's not a super high level. But this is where I run into problems. The messaging is very difficult. This is high, people have become sick at these levels. Is it alarming? Is somebody gonna die? That's tricky too, because everybody responds to the toxins a little bit differently. So our message of 80, the regulatory level of 80, I maintain that message, but then this is where I have people saying to me, I've already eaten that plant. So it's really opened up a lot of additional questions for our community. Another factor that we found in Old Harbor, we looked at 2 different subsistence sites, popular beaches. We have the Shipwreck Beach, which is on the town side of the Kodiak Straits, and Sheep Island is a very popular site. We saw, one day we went out, we saw about a 3-fold difference in toxins between the site. It's a half a mile apart. You can stand on the beach and look across at the Sheep Island. So I was hoping to go down there and see no difference between the sites and just be happy when they were able to collect a sample. So there's some really complex oceanography driving these dynamics. We spent 6 months last year taking a closer look at these 2 sites, and we did find that Sheep Island was consistently higher than Shipwreck. So this was a great concern for the community and made them think a little bit more. Old Harbor's been very active in this project, in these projects. There's a lot more work to do. We had a little bit of water quality measurements going alongside with this toxin, and I'd say we didn't collect the data that we needed to make any determinations or conclusions regarding what the differences in these 2 sites. That's why I was super excited to see Peter also working in Old Harbor, because I want this question answered. Why are these 2 sites so different when they're half a mile apart? I've built some really strong community partners, had a really strong educational component in this study. We've had youth in the classroom, we've had youth out in the field. The DEC project that we conducted here was actually managed by the school district, and we were in the classroom. The kids were out day and night collecting. You can see them out in the headlamps and out in the dark. It was pretty crazy. We learned a lot. This is not easy work, especially in our environment, especially in the winter. Tides happening at 10, 11 o'clock at night. So I commend everybody that was involved in this project. It was a real success in a lot of ways. I've been working with Old Harbor. Old Harbor's doing some dynamic work. Switgard Dusterlo has been leading the marine science camp down there, and I participated with her in that in regards to my project. I would participate in Nuniac Nuniac camp, their culture camp. I'd like to see these activities extending further than Old Harbor, and that was one of my interests too, in asking Peter that question. You know, can we get all of us around to all the villages? And I'm the Alaska Sea Grant agent for Kodiak, and I haven't made it to all the villages, and I want to. But it comes to funding to some point. I'm very proud of Joan Bernowski. I think you've seen her in the news. Joan's been helping me with a couple different projects for the last couple of years. And she went on, her interest grew in PSP, and actually this young woman has taught me so much being down in Old Harbor, and I've learned a lot by working with her. And she used the Scotia test to do her science project. I taught her once how to do it, and I let her loose, and she ended up winning, and she's going on to nationals. I work closely with the Kodiak College. We've been using the Abraxas ELISA. This is an upper level technique, and these students are first, second year undergraduate students. And it's real exciting to give them kind of the tools. So we go over the concepts of PSP and also work with them on these advanced laboratory methods. The test is rigorous. They have to concentrate. It's one of their longer labs. It's about a four-week lab. I work with Dr. Cindy Trussell. So again, we'll come back to this, can I eat the shellfish? And over these educational, the work I do in the educational components, I keep feeding back into my picture, my plan. I'm collecting all this data and trying to use every bit of it to build a better picture for Kodiak. And I still get this question. I gave you that sample, I ate it, and now you're telling me I can't eat it. And there's a lot of questions that come up around that. One of my concerns is for over-messaging. This is really tricky for me, and I'd love to have some dialogue with some other partners, including Chris, and we already have. But for Kodiak, I'm a little concerned with just constantly that message of do not eat the shellfish, do not eat the shellfish, do not eat the shellfish when people are eating it. But then when somebody gets sick, it's tricky. But this is the kind of thing I'm concerned with. And this is why I want long-term monitoring in my community, and why I'm working very hard to establish long-term monitoring. This is work, I'm sorry, I lost the citation here. This is work by Bruce Wright from the Aleutian Island Privilege Association. He established long-term monitoring out in a couple of communities out west. And for many, many years, they sampled and saw maybe a few bumps here and there in their toxicity. And then one year in June, they spike up to 6,500 micrograms of toxin. That will kill you. This is the level that will kill you. This is some butterclams. Comes back down, spikes up a couple years later. We don't have these long-term data sets for Kodiak, and there's very few in our state. This level of toxin, the 6580, was about the level that was reported last year when the woman almost died here in Kodiak. If she hadn't been at the clinic when she became sick, she probably would have died. So these are lethal levels, and this is where I hesitate with over-messaging. You know, it's a challenge. Although we all agree that when we see the toxins rising, we put out that alert. It's that cusp of, you know. But with continuous monitoring, I hope to achieve that. And Bruce Wright has also worked with his communities on this. Viking Cove is another astounding example of Viking toxins. This is, they went through 2 years of monitoring toxins and finding nothing, basically. That's a lot of work. You go out there and you find nothing, and then boom, overnight, they're off the charts. This is at 21,600 micrograms of toxin. 80 is safe. This is the kind of level that was comparable to the value of toxin that was reported with the death in Old Harbor. This is what I'm concerned with in my community. There's some other questions about toxin variability in the tissues. I hear a lot of people say, I cut the black tip off, I cleaned the gut out, I let the plants soak in a bucket for three days. And those are what we sometimes consider myths, but there's some pieces to it that are valid. So we're working on my current study to address some of these questions that the communities have. We all heard about the whales' potential toxins in our region, and maybe the ecosystem effects. I'm currently working with some partners to develop a new test kit that instead of a pass-fail test, it'll actually give us a numerical value. And I'm hoping, and I know the messaging will be very hard with this. I don't see a really clean way to do this. I expect to see that we'll continue to see the toxins, and then the messaging around the value, the toxin value is gonna be difficult, but I'm hoping that with the community being able to determine whether their sample is toxic at 80, or toxic at 200, or toxic at 2,000, they're gonna be able to make better judgment and better decisions for themselves. And certainly I know that the people that are interested in this are very educated on this topic, and this will give them a little bit more information to go on, other than don't know. So with that, I'll finish up. Thank you.
Thank you, Julie. Running a little bit behind, so we're just going to take a quick 10-minute break. Go have a cookie, have something to drink, grab the fresh air. We'll start right back up at 3:30. That puts it so we're just 10 minutes behind. That way we can end pretty close to 5 and everybody can get outside for 6 more hours of sunshine.
Couple feedback.
Hey.
That window
How are you doing?
yeah, for last when I listened to that time, and then I could almost see the pointer. I know this will be hard to see the. Anyway, I could hard to see and that you know that's so much better. And then the only other thought is could Kyle
I don't know.
because he doesn't have students. it's good. And if somebody does it tomorrow, they have the big screen, but I was thinking that might interrupt kids that don't want to participate. So I could at least set it up in quiet format on the big screen so they know what's happening, and then have them pull it up on the computer.
Yeah, and you have the agenda, so
Yeah, I have everything.
So.
And the first one I want to hear.
Yeah,
Because
well.
he did his work out at our first.
Oh, cool.
Okay.
Oh, okay.
I think it used to be June.
Oh, okay. I serve on the, not with recently appointed.
I think Teresa gave that call out without the mic on. So yeah, we're gonna start back up here and do the Teresa.
Thanks, Julie. Alrighty, next we just have, let's see, we have 3 more presentations and then we're gonna move into the community discussion. So keep thinking about what you'd like to see in our community. I think we're learning so much through the course of these presentations, and as community members, it's a great opportunity to think about what we would like to see moving forward in Kodiak and Kodiak Archipelagos. So next we have Will Copen with Axiom Data Science in Anchorage, and his presentation is going to be from collection to practical use, integrating and visualizing coastal and marine data. Thanks, Will.
You heard some expectations maybe earlier in the day. The AU's person would be here and talk about everyone's pet projects. And unfortunately, I'm not even an AU's person. I'm an Axiom data science person. So if Molly was here, she would talk about all the programmatic stuff we're doing. I'm not Molly. If Rob was here, he would show you the latest and greatest stuff. If Stacy Buckaloo were here, she would probably talk about the PSP kind of stuff we're doing. Instead, you get me. And my main job is to work with people to put data into the AU system and to work with people to make sure that the data that we're visualizing looks correct, it's showing up in a way that they expect, and it's easy to use for members of the public. So I'm just going to kind of show you a quick overview about AUS, just in case that is not your household name. And then I'm going to cross my fingers and we're going to go into a live demonstration. We're going to hope the internet here holds up. And I hope that that section of it is more like a conversation. So if we're looking at an area that you would prefer to look somewhere else, we'll just scroll over there on the map and check out what data is available there. First, AUS is part of the IUS Integrated Ocean Observing System. It's a US-wide thing. We're up here in Alaska at number 1. I bet there's a marker here. Oh, no, not that one. Oh yeah, okay, but you know, Alaska is up here kind of off on the one up edge of the map, but Axiom at least also works with the Central and Northern Ocean Observing System here. We work with the Southern Ocean Observing System, working with them for HAB forecasts. We work with the Southern on the Eastern Seaboard. We write grants with all these people. We just wrote a grant with the Great Lakes Ocean Observing System, and we just wrote a grant to study oil spill stuff with the Gulf Coast Ocean Observing System. So we started here in Alaska, but we're really kind of a national organization, and we hope to bring whatever we learn in Alaska to these other places. The AU's mission is first and foremost to provide easy access to data, and that's for everyone, for the general public, it's for scientists, and that's kind of a very broad goal and a broad mission. And the way that we do that is through building web tools that hopefully attack lots of different problems. So if you're a scientist, you can kind of go and drill as deep as you want. If you're just starting off and you're a high school student working at Kodiak High, you can kind of scroll around to different things and pretty intuitively find data and explore it. It turns out that when you aggregate hundreds of data sets, you can also start to do things like finding the gaps. So when you put every single real-time sensor in Alaska on a map, it's pretty much anybody that will basically take any kind of data. We don't work a lot with community-based observation data, but we work with any QA/QC data, and that could include community-based observations. We work with a lot of different data types. We're just starting to get into satellite-tagged animals, drifters and things like that. We've got a lot more of those on the eastern seaboard than we do in Alaska. We have lots of platforms, mooring shore stations, weather stations, buoys, wave buoys. Grids, so we pull in a lot of satellite data. For sea ice, we're just starting to work with MODIS data. And then lots of GIS layers, and so those are things that are maybe put out by, for example, Audubon puts out its Arctic marine synthesis. And so we draw on all that data and we try to make it available on maps. Then we do some kind of products. Okay, this is the prey part. Okay. Focus this towards me. Okay, so normally when I want this, and this is just to give you an indication that yes, you can do this. Like it's not a canned thing that only goes on presentations. So the normal thing that I do is I go to AUS.org. And this is the AUS website, and you can do stuff here if you want, but if you go to Access Data, and then I'm just going to go to the AUS Ocean Data Explorer. Like maybe I can even make this a little bigger for you. Okay. You get a little splash page telling you it's the Ocean Data Explorer. We have data from all around Alaska. If you go to Explore Data Layers, you go to our catalog. And so this is a catalog of all the data that we currently have in the AU system. You can browse over here if you want. We've got a real-time sensor catalog, historical sensor data, shore zone stuff, surge level guidance for storm surge, National Digital Forecast Database. You could go through this for a while. In each of this, there's 127 data sets that we have in here now. If you would click into, say, wave watch, there would probably be about 25 layers of significant wave height, swell wave height, wind-induced wave height, those kinds of things. So it's probably over 1,000 data layers that you have access to if you want it. You can just kind of scroll through and see what you want. You can also look on the left-hand side. We've kind of categorized these by tags. So there's CTE data, fish data, habitat data, etc. You could go to advanced search options. You could just draw a square around Kodiak Island and see what data is available there. You could filter by time and say, well, I'm only interested in data that's been collected in the last year. You can do any combination of those things to find data. Or you can just go up and search in the box if you know what you're looking for.
Can you draw a square?
Sure. Oh, I need to go to yeah, let's narrow it down a little more. Okay, so this says 45 data layers kind of around Kodiak Island, but that includes everything from very large resolution weather models to wave models to real-time sensors to a little bit of everything.
So that's just your search result. That's just your result.
Just my search results.
I expected it to pop up with all the clickables.
The clickables?
Thank you.
I like that one. Okay, let's see, I'm going to turn off my spatial filter. And I'm going to reload so that doesn't affect me. Okay, so first I'm going to just scroll through a few of our existing data layers, but like I said, if there's something that you would rather look at, just yell it out, and let's go look at that instead. This is our real-time sensor catalog. So all of these have a little narrative metadata blurb. This isn't formal metadata. It's just a little narrative blurb to a member of the public what is involved and what is in this data set. And these are all the real-time sensors currently streaming over Alaska and some portion of Canada. I'm going to change this to air temperature. And right now you're seeing basically hex bins of air temperature that are aggregated into kind of sensor blocks. So it's just gridding on the fly for you. And let's see, the lowest one is 17 to 63 degrees Fahrenheit. We're going to zoom in here. I'm going to see if I can find Kodiak underneath this. Okay. There we are. Here's a few real-time sensors. You can scroll over these. This is Kodiak Island. This is the airport, 47 there. Good for whales. This is Passage Shack Road, and you can get a webcam image. This is from, let's see, it says 2:20 p.m. today. So this is a quick way for, if you're a mariner, if you're a fisherman, if you're the Coast Guard, to say what are the current conditions right now. You could change this if you wanted to wind. It'll show you the wind temperatures. If you click on this thing, it says right now it's 5 knots from the northeast. If I click on it, it just gives me the last week's worth of data over here, and the wind rose showing me, you know, what direction that wind is coming from. You could expand it if you want. And then you could explore it by just scaling down and dragging and find out, okay, well, yesterday, where was the wind coming from? And you could just use the x-axis to find and bracket yesterday and find out if the wind was coming from that direction.
Well,
Yeah.
if you hit the download, what do you get? Do you get the actual file, or do you get?
Yep. So yeah, if you hit the source button, it goes right to the sensor, the NOAA sensor page. If this is from NBVC. If you hit download, you just get a CSV with it'll give you the station kind of metadata, where the station is, where this came from. Yep, and a CSV of time values and magnitude, basically. If you're more of a programmer person, I don't know if people in here use ERDAP or Threads, but if you are programming in R, you just want to pull these things in normally, you can use things like ERDAP, and that is a NOAA-sponsored, I guess I won't go into it because it's beyond the scope of this, but it's a NOAA-sponsored way to programmatically bring data into any program. Okay. Let's go look for some other data. I'm going to go to Shore Zone. Here's Shore Zone imagery. This is a program that goes around and flies the coast of Alaska at low tide. And basically they are trying to map the coastline, and then they categorize that by biological wave exposure, by what they're seeing on the ground. But I like to think of it as street view for coastlines. And let's see if we can zoom in here. Okay, gonna go down here. I'm gonna hit this portal button, so it takes us into the portal. Before we were just on the catalog page. Okay, I don't really know where I am because I'm not from Kodiak, and so instead I'm going to switch my base layer and I'm going to go to NOAA charts. Okay. Now I know where I am, and I'm seeing the data, the shore zone track line along NOAA charts, so I can tell at least where I am. If you don't like NOAA charts, maybe you like USGS topography instead. That's fine. I'm going to go back to the satellite layer. If I roll over here, I should get a little preview pop-up of the image, high resolution image that they took along that track line. If I click and the internet is okay, it'll start the video playing. We'll move along this track line so you can kind of see us moving along here. We'll zoom in a little further. So you can see the high resolution image on the top. You've got the high definition video on the bottom, and we're moving along the track line. So this is like an easy way, we hope, to very quickly get at this data. And I use this all the time if I want to go on a kayaking trip. I'm going to look at the shoreline before I know if we can land there. If you're talking about oil spills, people want to know this all the time. Okay. I'm going to show you one more thing. And this is just a big gridded model. So it's from the NAM, the North American Mesoscale model. And this is basically where almost all of our weather forecasts in Alaska come from. And we can do wind at 10 meters. I'm going to turn off the shore zone imagery. And I'm going to back out to show you Alaska. Maybe more. All right, so here is the wind nowcast for right now. If you wanted to, you could put in the wind sensors that I just showed you, the real-time sensors, and you could compare the model. What does the model say that it's going to be to the sensor that's right at the end of the pier? You can scroll over it. If you just leave your cursor set for a second, it's 16 knots. If you go over to this big stuff over here in the Grand Sea, it's up to 40 knots out there. That's pretty harsh for me. Yesterday we could see all the gap winds coming through the Alaska Range. Let's see, what am I going to show you? I'm going to show you one more thing because we just have a few minutes left. And this is not near Kodiak. Oh, not subsistence. Let's see, what would it be called? Oh, socioeconomic. I'm going to show you some subsistence data that we worked with CONES to put in. And this is kind of just an example of how we could take subsistence data from around Kodiak, or anywhere, and visualize it. So this is St. Lawrence Island. Here's Savunga, here's Gamble. And this was a program where a lot of fishermen on the island basically drew a circle. They drew kind of a wavy line around like where they fished and what they caught. And that was kind of the extent of it. So they didn't say I was fishing here on this day and this is exactly what I caught. They said this is the area that I tend to fish in and this is what I fish for. And so when you collect that from 150 people and take all those polygons and layer them on top of each other, you can put together a density map of where people in this area are actually fishing at any given time. But it's anonymized, so no specific person has their like data or information like revealed on the web for everyone to see because they don't want that. You could look in the spring seasons, summer seasons. You could change the species. Let's go to salmon here. So this is the summer salmon, spring salmon, winter salmon. If you scroll over it, you'll see like how many people said that they fished for salmon in that area in the winter. If you click on it, it'll just give you by season. So it's the harvest effort by season in that hex span. So I see some people nodding their heads and being like, oh yeah, I've seen all this before. And I see some people very confused and saying, but that's okay, this is where I come in. So this is pretty much all the time that I have for this presentation. But I should say that we're really nice. Like, people at AUS and Axiom are really nice. And I think if you talk to anybody who has talked to us, you'll find out that, man, we're very responsive. And we want to help you put data into the system, and we want to help you get data out of the system. So we have this big red feedback tab here. And that doesn't just go into a black hole, that goes to me, and it goes to like 5 other people. And we probably will respond within an hour if you're like, I can't find the data that I want, or I can't find this type of data. I can easily write back and say, okay, well, we don't have that data, it doesn't exist, or, oh, we have it, it's just not labeled in the way that you thought, or whatever that is. So we are very good at that feedback tab, and please contact us. Shut down Chrome. Is there anything else that I want to talk about? Nope. That's it. Here's 3 emails, including Molly's. Rob, he's my boss. Will, that's me. Feel free to write me an email or ask after any data, or if you have data that you want to put in, please contact us. Portal.aus.org gets you to this data portal. And that's, of course, a picture of termination point, which I hope that you can get out to while you're here. Okay. Any questions?
Thank you, Will. We have time for one question for Will, and then we'll be moving on. Let's see. There first. Yeah.
I had a question for you, Will, about you were bringing up that socioeconomic data.
Yeah.
Are those data downloadable in tabular or spatial form? Like, could I get GIS data for that, or could I get a tabular spread of those data?
No, no. The reason, basically we're working with CONAS, and they have like 16 villages between the US and Russia, and basically they go back to each individual village and vet it with elders and community members and say like, can we do this? And basically time and time again, they were like, we are fine with displaying it on the map, we're not okay with having anybody have download access to it. But that's just the nature of this data set, not all subsistence, it's just for this stuff.
Do you have something, Art?
Yeah, there's something I wanted to see added several years ago. I was at some workshop, we're discussing shore zone imagery, and I was a little disappointed that there wasn't any display of the approaches to the shore, like in case of an oil spill cleanup or something like that. There are all these great shoreline views, but how do you get a vessel onto the shore? And I suggested at the time this new high-resolution NOAA imagery that's becoming available, particularly in the form of GeoPDFs. So have you thought of adding something like that so we can clearly see the approaches rather than just what's above the water line?
Yeah, we have, and we did.
I highly encourage folks to explore this website. It's fascinating.
Well,
it's a great resource for mariners.
And you kind of, unfortunately, sorry that nobody got back to you saying that they added it. We need to exchange those, but at least we have some of it. We don't have like multi-beam tracks, which maybe that's what they want. But we definitely have all the latest stuff that's put up by NOAA. So for the Aleutian Islands, Gulf, Cook Inlet. Cook Inlet is a little better than everywhere else, I think, just because they have more people going in there. Norton Sound. This one's not as good, the AMR, but yep, the other ones are pretty high resolution.
And then the imagery is tied into the shore zone?
It's not tied in directly to the shore zone, but you can load them both up at the same time. Yep, you just load both layers at once. If that makes sense. And I can show you how to do that too.
They're very nice.
I know.
Great picture of Termination Point. It was just granted a permanent conservation easement effective April 8th, 2017.
I know, go
Kodiak community. Yeah, it was great. Okay, well, last up for a day until we move into our community discussion is Tom Lance with the Sunak tribe of Kodiak, and Tom will be talking about Kodiak. It's the final report. They've been working on this for quite some time, so thanks for sharing this with us today, Tom.
You're welcome.
Good afternoon, everybody. Thank you for sticking around. I'm here to do cleanup. Hopefully, after we're all done here, tonight there's a good banquet, I guess. So, this report is due at the end of this month. So, it's almost there. Yeah, we're in the bush. There's some little cleanup going on it right now, even though it does say March. On the next slide you'll see. But I want to thank everybody that's been involved. It required a large group of folks, teamwork approach from a group of folks. And for this purpose of this presentation, I'm just listing the first few that were most instrumental. And first off on the list, Kathy Drebeck, who's now retired. She was the initial start of this effort, and then I stepped in to finish it off. Kelly Kruger, our tribal biologist, has been instrumental in this. Sean Hales, assistant, who works for Sunak. Erica McCall Valentine, who has a consulting firm called The Scholarship, She has moved to Fairbanks, but she still works with us a little bit. And then Shubha Pandit, he's a statistician who helped us save the day at the end when we had some statistical issues to deal with. And you can see Shubha is with Terra Aqua Environmental Consulting in Antioch, Washington. Just last week, I pulled this guy out of my compost pile. No, not really. But we had one heck of a icy winter, and I just thought I'd pop this up here for some of you who are visiting right now. This is not what it's normally like out here, and there is some weather coming, so I hope it doesn't cancel our effort for the barbecue. And on Saturday is the big, beach cleanup, and I don't know, it's supposed to be blowing pretty hard and lots of rain, and hopefully you guys that are on planes, you get out before it hits. So.
Don't run down.
Yeah, but this is just 10 minutes, 15 minutes that we have left. There's not enough time to cover everything. There's 57 tables, 20 graphs, 161 pages, several years of work, all being boiled down here. And the bottom line is that Kodiak tribes eat more fish, but when compared with most people in the USA, your intake may vary. I'm the Natural Resources Director for Shunak Tribe, and I have the pleasure of trying to encourage other people to use our resources wisely, and everything that we do is based on tribal council wishes and guidance. And when I first started working for the tribe, an elder who has since passed came by and pounded his hand on the desk and said, "Thomas, if there's one thing you remember, tribes are about food and culture, and the corporations are about the pocketbook." And then he got up and left, and he didn't talk with me for a long time again. But after a while, we developed a rapport, and that was Ivor Malutin. And the thing is that tribes are bound to the marine resources. That all the tribes that live along the coast here, we have primarily the Sukyak Alutiiq people along the coastal zone of Kodiak on up into Cook Inlet area, and then you have the Yak people over towards Yakutat and that way. And they all rely on subsistence resources to a great extent. And so what we tried to do was quantify that. And it all started back in 2010 or 11 when there was a survey done that we noticed that tribal members relied heavily on subsistence resources regarding salmon, for example. And so the question is, well, how much? So we tried to quantitatively determine that using representative communities around Kodiak. There are 10 federally recognized tribes on Kodiak Island. And we chose to select the largest tribes and also the ones that we were able to fit into our budget and logistics and demographics and that sort of thing. So Larsen Bay, Old Harbor, Port Lions, Yuzinki, and then finally Kodiak, where Shunak tribe is based out of. So again, back in 2010, there was this concept of let's look at this in more detail about subsistence. And so in 13, we started the assessment work, and then the actual field work portion, going out to all the villages, interviewing people, took a team of people, worked with the village representatives, and we interviewed folks, put it in a database. That all took place in the period from October to December 2015. It wasn't ideal, but that's what we had to deal with time-wise. And we received our funding from the EPA's Indian General Assistance Program, IGAP. So the concept was that salmon, like other seafoods, are especially important, and we most likely eat more than a national average. Aleutic people might be accumulating toxin loads at greater levels when compared to the average American consumer, and that's what we wanted to explore, because that raises alarm bells if we're basing water quality criteria, for example, on a certain level of intake. Well, if tribal members around Kodiak Island are eating more fish, then they could possibly have a higher toxin level. So that's how this developed. And again, the purpose, these are taken cuts straight out of the document. I'm not going to read them all here, but I'll just try to summarize it quickly. The hope is that this information will be used by state and federal agencies and other tribes when trying to build capacity or technical assessment tools to evaluate the health risks to tribal members and everybody for that matter. We don't want to, this is similar to the discussion that Julie, the point that she raised about shellfish consumption, clams, and you don't want to tell people not to eat it because it's toxic, but yet they still eat it. But you don't want to raise an alarm bell that unnecessarily, but they still want to eat their food, and so we need to somehow find more ways to teach people about what's safe, what's not, but yet do it in a culturally sensitive way and in a scientifically based way. So that's what this is about, again, to establish a credible seafood consumption rate for the subpopulations of Aleutic tribal members. And for this study, we talk about seafood as including all fish, shellfish, seaweed, marine mammals consumed locally with no regard to source. Not all the villages have grocery stores, and they'll come to town. Obviously, they'll come to town and buy something, and if they said they bought catfish fillets and they ate it and it came up in the survey, when we talked to them, it's in the survey. So when you look at this and you say, when you dig into the data and you say, hey, catfish, where do you get catfish around Kodiak? Well, that's why they bought it at the store. But we did incorporate the three methods, and obviously literature search is fundamental to every research project, but the other two ways of doing a food survey involved the 24-hour recall assessment method and then the food frequency questionnaire, or FFQ, which covers an annual consumption rate. And while we were doing this project, the EPA had been in the process of revising their guidelines as to how to assess food consumption, and they've now moved towards a methodology that's followed by the National Cancer Institute, the NCI method, which is a blend of both the FFQ and the 24-hour recall. So again, this is a large project, this is a pile of data. We're just touching the tip of the iceberg. Somebody hopefully can take this now and mine it use it as a platform to move on to another level of assessment. We actually looked very closely at what Seldovia tribe did. They did the Cook Inlet survey, and this is built upon that, as well as all the other surveys that have been done by other tribes in the Pacific Northwest, Puget Sound and whatnot. So, what was the study? Well, we looked at just raw weight consumption of all seafood types in terms of gram per person per day for 5 of the 10 Alaska Native or American Indian communities on the archipelago. 5 communities were grouped into 3 subpopulations for statistical comparisons. We did not try to tease out any information about prehistoric or historical harvest and consumption rates. Something to celebrate. Well, Kodiak tribes consume seafood at a very high rate. The consumption rates are many-fold higher than tribes from the Pacific Northwest, and 10 times the rate of the US population. That's what we found. Salmon is one of those important seafoods. In fact, it's probably the most important seafood consumption-wise on the archipelago. And I know this is a tough box and whisker graph to see, but just to make a point, you can see these are individual observations where these dots are going up. We've got some consumers that are eating up to 700, almost, well, 650 grams of seafood per day. Now, again, this is raw weight. But you can see I also highlighted a couple of the others that were significantly higher than some of the others here. Our cod, halibut, things that you would expect for Kodiak. And I also wanted to point out sea lions on here too. I didn't want to put the folks on the spot yesterday and say, hey, wait a minute, tribes eat seafood, sea lion too. But sea lion is very good. If I could harvest it, I would. I'm not a native. But I was at a banquet once, and somebody brought a pot of sea lion stew, and I'll tell you what, it was really good. I'd rather eat it than cow. So we have to figure out a way to manage it sustainably. So I back up here. I didn't say, I didn't tell you this. Larson Bay and Old Harbor and Port Alliance and Yazinki both they all eat more salmon than Kodiak does. And I was at another talk here recently, and somebody said, wait a minute, we eat more salmon than Kodiak. And I said, well, I think the reason why we don't eat as much salmon in Kodiak anymore is because we probably have Big Macs and KFC and things like that here in town, you know, out in Old Harbor. So, you know, little things like that. Elders will ask a question that, you know, you don't want to be offensive, and you want to be informative, but it's been interesting working with them, trying to express this information. So, what did we find? Well, here you go, 24-hour recall rate and the FFQ rate. For the entire population, all averaged out, the mean is 359 grams per person per day. FFQ rate, 232. So these two different methods at least show that they're both high. And then when we go to the next slide, and I'll show this in another way, but the summary is that only one other tribe in the Pacific Northwest had rates that were comparable, and that's the Squamish tribe in the Puget Sound area. So nearly 1.5 times greater than that for the Chauvin tribes in Idaho, almost 2 times greater than that for the Nez Perce tribe in Idaho, about 2.5 times greater than Cook Inlet tribes, or Cook Inlet, Tulalip and Tulalip and Squaxin Inlet tribes in the Puget Sound, and of course the Seldovia study was the Cook Inlet. And 3.5 times greater than that reported for Columbia River tribes, and again 10 times the amount for the average U.S. So what is the average U.S.? It's 23.8. That's what EPA says now, but they think that it actually is higher, so they're reassessing it, and it's regional too, it depends on each region. But right now, water quality standards in most states are, that the EPA is, this information is provided by EPA to states. The water quality criteria, for example, for a contaminant loam is based on the consumption rate of only 23.8 grams per person per day. But if we're eating salmon alone, if we're eating 125 grams per person per day, then maybe we should reevaluate what the potential toxin burden might be to somebody if they're a native, or somebody living out here who relies on subsistence resources. So in conclusion, I'd like to read these couple of statements. Lutic people and many other Kodiak Archipelago residents are no doubt opportunistic harvesters and consumers of local seafood due to location, seasonal availability, and weather, gear accessibility, commercial fishing activities, and state and federal regulations. Establishing the cultural and economic values of these foods could help strengthen our regional stewardship policies and programs, as well as ensuring that all residents subsisting from the Gulf of Alaska resources will continue to thrive. With that, thank you very much. Koin Asanak. Any questions? And we can always talk about it.
Have community discussion next? Yeah. Okay, well, thank you, Tom.
So when does that go on? Is that available online now? Or?
Oh, yeah, and my information, our website, chunak.org, all this data will be on our website in May. If you have any questions, call us, and we encourage you to take the data and run with it. Thank you.
Great, thanks, Tom. Encourage those who can stay for a little longer to stick around. We can have a community discussion that David's going to facilitate, particularly our presenters. Where did you want folks? Did you?
Close to the front?
Then move on up.
Do you want to move the tables over or just go over?
Oh, this is fine, probably.
Go over.
Yeah, we'll move it that way. Good. There is a reception this evening. What time does that start?
6:30 at the Kodiak Victorian Science Center. It's a community reception, and one thing we still have up, we have the Sailing for Salmon exhibit. So if you haven't seen that, it's really nice.
Oh, it's really great.
Yeah.
Okay, so to start us off, I thought I'd just do a quick recap of some of the things that we heard today, most of this afternoon, and then kind of lead into maybe some more discussion. And I apologize if I don't get all of your points correct. I was listening to certain things as we were going through this. So to start with, Marilyn talked to us a lot about education and the goals of getting teachers in the classroom engaged and also community education. From there, we went on to the school, and I was very impressed by the students. Amazed at the technology, and that one of the things I got out of that was that students are really our future scientists and have this ability to work with that technology. And technology is something that is becoming more prevalent in rural communities and has the ability to really facilitate some of the data collection and getting that out. And I think that was kind of picked up by Peter Windsor when he talked about long-term consistent collection of time series in communities and engaging, working with people in different communities to have them collect data that he could then put into a database and put right up online so that they can actually see the fruits of their work or their labor. And talking, especially focusing on that nearshore environment, and that continuous measurements really are important. And I think also Bob Foy pointed that out as well. He's talked about OA sample sites in Southeast, Prince William Sound, and down the West Coast. And then, also looking at Kodiak. And one of the points he brought up that I really found striking was that Kodiak's a really good lab. You've got different current oceans basically on either side, different water chemistry, and so it's a really good lab for that. When Will was talking about community-based monitoring, I thought this was interesting that communities could put in their information, and I actually have a project that will add some more socioeconomic data to that, hopefully soon. It just got funded. And going back a little bit, I wanted to just mention the work that Julie's been doing, and of course the Sitka tribe, and trying to get some of this technology back into the hands of communities so that they can do their own TSP monitoring. And Chris talked about to, listening to the communities about their data gaps. And I think that's one of the important points I wanted to bring up is that, listening to the communities, what data gaps are there, and trying to actually meet those data gaps that aren't being met by other programs. And SHUNAC, to kind of finish here, is working on some of that. And I had the pleasure of talking to them when they first got started on that project, and it was great to see that. And just wanted to mention that that was going to be picked up by people in Southeast Alaska as a model for fish consumption surveys. And so SHUNAC is working to kind of also meet those data gaps up there. And also to collect data in a scientific way, but be culturally sensitive and to have buy-in from the community. So I'm just going to leave it with that. And if you guys have questions, you can direct them directly to our panel here. If you don't have questions, I'll try to think of something. So, and I think Teresa also has some questions that or some things that she wanted to discuss too, as we were kind of thinking about what we wanted to go over. So, and I'll bring the microphone over if you want to use that.
One thing that just reminded my listening to all these talks this afternoon was there seem to be a lot of projects going on that are looking for community involvement. But being part of the community, how do I know who to call? For example, when we have a sea lion entangled here in marine debris in Kodiak, I mean, by now I have informed myself and I know who to call, but it's actually hard to find that information. If I'm out there making observations, what came to my mind is the need for a central number, kind of a central address, an overarching umbrella to bring all these projects together. I also see the danger with the rural communities when we go out there starting all these different projects that they get kind of tired of it when everybody comes with something else and different methods and everybody wants something else. It can get tiring after a while. So how do we do a better job of coordinating all these projects?
I think that's a good way to start, actually.
And actually, Switzerland, that was my question for our panel. That's one of the reasons that I really wanted to bring this discussion. And I know we're not going to answer that right now, but David is an awesome facilitator and he's skilled at having these community discussions. And I thought we would at least have the start of this. But I agree with you, Stuttgart, on that. Sometimes we come at the community with our own projects and interests, each of us individually coming to a community, and sometimes we end up, and I'm guilty of it, I feel it, I'm coming because I have a specific need, I want to continue the work that I'm passionate about, so I look for community partners, and then Peter wants to work with his passion, we're all doing that, and I'm wondering if there's a way that we, as scientists, agency, and educators can leverage our skills, work together. And I honestly don't know if that's the best approach. Like if we form this consortium that says we'd like to work with Old Harbor, for example, since they're doing so much. We'd like to work with them. We should all approach them as, this is what we have, suite of, for them. I don't know if that's the best approach or not. Or do we continue to do individual work and try to find those partners by ourselves? But I think that it's worthy of a conversation.
Fantastic question. I think first what we need to do is define the difference between monitoring and just process studies. Very little of what we've talked about is really truly monitoring.
Like I said in my presentation, if you're not still doing it in 10 years, you're not monitoring anything because of the amount of variability in our system. So, you know, I think if there's process level studies that can be done in concert, that's great. But I think that unless you're truly going to try and build a monitoring program, it's going to be on different scales. Everyone's got their own agenda, they've got their own funding, the funding is short. So I guess from my perspective, and a little bit of background, I've been trying to do this for 20 years with different Partners in Science program, EVO's funding when they first started. I had temperature loggers in all the communities. We were doing ocean monitoring, and the interest has to be sustainable. So number one, define the difference between monitoring and process studies. Two, when you start, decide how you're going to make it sustainable. If you've only got 2 years worth of funding, it's very difficult to then get a bunch of other people together to collaborate in that long term. That's not to say folks shouldn't collaborate. I mean, obviously we should be working together when it comes to collecting temperature and fluorometry data, et cetera, associated with phytoplankton blooms, which you're interested in, and it fits in with the acidification. So I think it comes blathering on here, but I think that it comes to the organization at the beginning. Are you truly monitoring, and how do you make sure it's sustainable for the long term? And then I think in order to get the other groups involved, it's a natural. I mean, this meeting would do that. Again, I didn't see any monitoring, except Peter Windsor's work at Old Harbor, which is monitoring across here and multiple other locations. The rest of us are just talking about it. So, my 2 cents.
But to follow on that, as Marilyn pointed out too, it's a difficult process. So I would like to establish long-term monitoring in my community. The 2 communities that I ended up working with was using Old Harbor initially because there were funds in place for me to start doing that. Now, because I've got my 2.5 years, I would love to keep building on that because we've got this hodgepodge of information for Kodiak that drives me crazy. I've got my graduate work here with this here, and I even look at my own work in the Kodiak road system and I'm frustrated that we don't have a spot, but it opens up all these other questions. But I stopped short. I mean, I would like to have that, so I have maybe a process study or a short-term study, but I want more. So, and I think that some projects will have to just keep building on themselves, like the work that Bruce Wright has done in the evolution for blocks. There's some stops and starts, and there's some missing data, but in the end, after many years, they got it, and they're almost there where they're sustaining. And now, after 10 years of one location of PSP information, we can start to see something, because by not having this long-term monitoring, we have nothing to go on. So it's my 2 cents, like, that's the problem. So yes, we all want that perfect world as we start, but we also have to build.
Chris is doing this too. Yeah.
Well, there was kind of 2 questions. So the first question, when you said, where do I go to, or who do I tell? David should really answer that because he's in the process of building a place that will potentially house all those things. And so there'd be one centralized location that has all that kind of information and links to other places to get more. And you can speak to that more than I can, but I think he's got a good momentum with it. There's a lot of partners working together to help him kind of populate that site. So I think what's the name of the site again? Adaptalab, yeah, changed last time I heard of it. So that could be, you know, an easy one that people can go to say, who do I call if, you know, there's a sea lion doing this, or there's, you know, a tree across the road, but whatever it is. And then as far as, you know, going into villages and communities and starting projects, our success, and that's really all I can speak to, is really because the community came to us. It wasn't, you know, it wasn't like a federal or state agency was coming into a community saying, we have this project and we need you to do X, Y, and Z so we can have our data. It was the community coming together through the tribe and through their staff on the council's perspective, but from the staff and the people, and then bringing it up to the councils and having support across the region on that lower level, just the citizens wanting something. Ours happened to be, Shellfish and PSP, but as soon as that network was formed and those relationships were built and the trust was there, that's when other projects come online. With our ocean acidification work that we have kind of about to spool up here, it all is umbrellaed under this need to protect subsistence resources. I think someone else mentioned it's all about filtering food. And that's what it comes down to. If things are going to be happening that could affect the ability to harvest or maintain certain cultural pieces, that's what the community usually kind of leans to. So when it all comes down to it, really, if you can help link it to something, and it's not very hard to do with subsistence foods. Most of the stuff everyone's doing is related to that somehow. OA stuff eventually is going to have this trickle-down effect to bigger trophic species like was mentioned earlier. So, but I think utilizing the folks in the village and then the staff to kind of work their way up versus a top-down approach it worked for us, and it's still growing. So I think that way you don't get overwhelmed with someone coming in and saying we need all these things. If you have a couple simple ideas that you just want to start with, it's a good starting point. I don't know if that answered any questions.
Google. And again, for us as a tribe, I work for a tribe, and the largest tribe actually, membership-wise, in the Northern Gulf. Our members ask us to help be vigilant and protect subsistence resources, and so staff, we talk to them and they say, hey, we used to eat shellfish. Why do you tell us not to eat shellfish? We're like, well, people are dying, and your uncle died last, or story about somebody dying, and we've got people in the tribe that have relatives that have died or nearly died from eating shellfish in one particular place. So let's do some research on that and try to answer those questions, and in the meantime share with everybody else, because as you know, the world's population has doubled since 1960 from about 3.5 billion to 7 billion. There's just more of us, and we need to be able to use our resources more wisely and share information to ensure that we have safe foods to eat forever. So how do we get together and all work on the same page? It's not going to happen. There's just too many, a variety of interests. And so the best thing we can do is in our camps, like here today, all of us are interested in marine ecology and biology and seafood. We need to at least have conferences like this and share information. But as far as I don't think it's possible that there's going to be one place, a clearinghouse for all this information.
When I first started my position with the Alaska Sea Grant, like 6 years ago, I was asked a similar question. Can we have a local portal where we dump in observations of information, and can it be Facebook or something? And there's a big, who's going to manage it? The data portal. And I look over it at XM. Because it's a big deal, like even like Facebook. So you might get caught up on this huge conversation back and forth, and I never can. Like when the questions go up for PSP, I'm usually actively sampling or something. But one of the suggestions had been, can we have a Facebook page for Kodiak, like Kodiak local observations? And Leo Network has tried it. I think it's an ongoing conversation, and there might be a solution for that. and we have to work towards it. I just wanted to swing back to what Chris said, and we all know that projects work best when they come from the bottom up. And all the data I showed you, the first 2 sets of data from the 2 villages, that was a very top-down project. That was a very difficult project, and I was put in a position, because I love that topic, that I was acting as a science advisor on a project that was a top-down project where the money was coming and asking these communities to go do that. And then the second project from Old Harbor was then their interest in the topic, and that was very bottom up. And I think Chris is right in that. So, and I appreciate Chris coming here. I know he's been having conversations with the Chinook tribe, and at least for that topic, there is interest for the local, you know, the foods. But I think Axiom and AOS are trying to fill that big hole, where to put the data parts. And
I could speak if you wanted.
Oh, go ahead.
But if you
No,
have a
please.
question,
I didn't, I'm sorry,
No,
I was in my own head and I missed that part, so please.
Yeah,
I don't want to.
and that was one of the, no, and I was gonna ask you that next, because I think it speaks to a little bit of what Bob's talking about, this continuous data and where it goes, and, you know, building the site to monitor, it's basically, we would just, if somebody came up about ocean acidification or monitoring, we would point to Axiom or the Oscotia acidification network and say, here's where you get your information. So what role does Axiom have in kind of collecting all this? And I, you know, you guys have been around for a little while, but it would be great to understand a little bit more about how you're going to collect this data into the long term.
Well, first, I guess we don't collect any data, and even AUS collects very little data. So I think of that as aggregating data. I guess that to me is like imploring people to share their data. You know, like if you get to 5 years of monitoring, you know, that should be online somewhere so that people can see it. Not only so that other people, you know, people in the community can say, oh, I was helping take that data, or I saw them out in the boat, you know, that day. Like I think that's a good feedback so that people don't get, you know, whatever, science tired of filling out surveys. If the information actually gets back to people, I think they're more amenable. And especially even in these subsistence surveys that we did, like all of that, having an organization that's not us, who worked in those communities, who took that information back to those communities and showed them, and people are like proud of like having filled out those surveys, and they're proud of like seeing. And I think that's, you know, well, we're fish than Kodiak. You know, like people want to know that information, and that's like good feedback. But I feel like I've seen a lot of scientific studies, especially that go to publication, and you know, and that's it. Like it's $50 to buy an article, you know, on Nature, and you never see the data that you helped collect. So in terms of like AUS, I know that we're kind of like a statewide organization, but we develop a lot of specific applications. So we have like a Cook Inlet Beluga portal, and that's like specifically targeted for Cook Inlet Beluga. And it wouldn't be hard to do that as a community, you know, like a Kodiak portal that specifically has layers for Kodiak, and might have like a link to, you know, an external information page. I mean, those things would be pretty easy to set up.
How much does it cost?
That's beyond my pay grade. But something like that could happen. Yeah.
Who would usually contract that with you for a region? Is it the city or the borough, or where does it come from?
So far, I mean, all our different applications have come from different sources, and some of them are agencies, a lot of them are grant funded, so it's a specific grant to say like, oh, you know, we have a Cook Inlet Beluga ecosystem whale portal, and it was like a NIFWIF grant for $50,000, I think, to put that up and maintain it. But ultimately, like AUS has a big budget to keep maintaining that stuff. You know, I think sometimes data comes into this system or it goes on a local webpage and then the person retires, or nobody's keeping up that webpage anymore, and then the information just kind of slowly dies. Whereas like AUS at least has the infrastructure. You know, we don't have a ton of money to to give to every project, and we would look for funding. We would go after one of those funds to start out a Kodiak page. And we'd work with tribes and basically find the money to do that. But then AUS has money to keep it going into the future, I think.
That's what they told us.
Oh, yeah.
Yes, Chris, how much does it cost?
True.
That's you're doing. How much is it?
Well, I guess it kind of depends on what you want. You could have like the kind of low-end version, or you can have the Rolls-Royce version. Those were Rob's words, Pinto or Rolls-Royce. What do you want? And I was like, oh, like a Ford? Like, I don't know. But like for what we're doing for biotoxins and phytoplankton, which everybody's gonna be able to access and use, the initial cost was like $25K to build it, with the hopes that other people will be able to put in more funds to grow it. But the selling point for me to throw money at it was that AUS was going to house it and maintain it with their infrastructure, because I was about this far away from like buying hardware and software and building it in Sitka. But I'm a biologist. I'm a terrible web guy. Like I'm not very good at that part. So and like you mentioned, you have to hire somebody and someone has to deal with it, and then if they leave, which a lot of times that happens, you got to deal with how you're going to correct it. So it was a no-brainer that AUS offered to support it. It just needs like some seed money to kind of build the thing first. So at least that's our situation. I'm sure every other application is different.
Can the students do it?
So, I'm a teacher, and I've been with the school district for a long time, and right now my job is connecting people, largely. And I'm the virtual content and STEM coordinator for AK Teach. And in my position right now, connecting scientists with students is a big thing. It's what I want to do, and what I do as much as I can. So it just seems to me that maybe we could talk to our local scientists and say, do you have some monitoring that K-12 students could do? I mean, kindergarten students can get a vial of water and send it to you. But I think, I can't remember who it was, he's left. The thing that he said about immediate feedback, immediately knowing and seeing the results of their efforts was huge. And it will be huge for any kid, for anyone. So, I mean, in my position right now, I can see AK Teach bridging, the scientists to the students. And if we can get AUS on board to keep that data, that would be amazing, because we could start teaching students to check AUS all the time and become very fluent at that and see the results of what they've been doing. So I think we have everything we need right here to do something, like today. I'm good. So anyway, that's my 2 cents. Let me see, I made some notes. Did I miss anything? Oh yeah, so one thing is keeping it manageable. I mean, one thing I've found, we have a ton of teachers who would be totally into and jumping right into this, but sustaining it all year long with all the other things they have to do would be impossible. So sharing it among everybody and saying, who all wants to gather water samples for ocean acidification? Well, we have 5 teachers who are interested in that. Let's split the year into 5 parts, and your class is in charge of it for this amount of time, and that way you can talk to these classes and interact and share the load and share the responsibility, and that makes it doable. We have the people for that. I can see it happen personally. So there I am. That's all.
I was just going to mention, historically, NSF has loved things that incorporate students. And especially they love things that incorporate lots of organizations and students. So that's the kind of thing that we should put together a few people and write a grant together.
I'd be glad to write a letter of support.
Yeah.
Since I'm not allowed to write an NSF grant, it's a fantastic idea. And there's a lot more funds available in the academic world for these types of long-term programs. Couldn't agree with you more. An NSF type grant to do this and incorporate K through 12 would be fantastic for a lot of these.
I would kind of like to see a panel of you guys, you scientists, just doing a Q&A with the kids. Present what you want. Say, we would like this to be collected for this many times a year, whatever, and let teachers ask questions. It could be a giant Blue Teams meeting or something. You know,
We
just
do
talk.
something similar in Sicko. We have like a science bowl every year.
Perfect,
And
yeah.
so right now, there's 3 high schools, believe it or not, in Sicko. 2 of them are actively working with the tribe on 3 different projects. So one is the PSP project, and the kids go out and every week, their class, and then one of the students takes it on in the summer as their summer project, and they get credit, and it's really cool. But they go out and they collect the phytoplankton, they collect the temperature and salinity data. They have a basket of mussels that hangs in the harbor that they go and they get their mussels at. And they learn all the process. And they spend, these are all seniors, most of them. And they come over and they figure all these pieces out, and then they put together a paper, a poster, and they present at this little science conference that we hold. And then there's a stipend attached to it if they enroll into the university system at UAS. We have funds through BLAST, which is Bio Learning and Student Teaching through UAS. It's a great program for undergrads, but it's basically like $3,000 a semester, and they get credit, and they get partnered up with a project. So we have 2 BLAST students, one that we're going to get next fall that is graduating this spring from high school, and she's rolling right into this blasting. So it's not the young folks, but it's that upper level high school and transitioning to college. Because one of the big things that we're missing are these students in these outlying villages coming into science. And so this is a way that we're working with outlying communities, and we're off the road system in the southeast and not attached to folks. So it's really hard to get a lot of those juniors and seniors to go to college. So this is kind of a way that they can work with their tribe during the summer or during these programs, and then they come over and they go to school at UAS, and they go back in the summer and work. And they're all funded through the university. So it's not like the tribe has to put up money or they have to find a job. It's all linked up. So it's an NIH proposal or a project that BLAST got, and we're linked up with that pretty uniquely.
Are you the contact person for that? Because I would love to talk to people to get more details.
Yeah, I can give you a whole laundry list of
Awesome.
folks.
Thank you.
And then the other piece to that, though, just the high school stuff, the easy things to collect, like temperature and salinity, all those data, at least for us, they're associated with phytoplankton, are going to be uploaded to Axiom. So if there's a group in Kodiak that wants to start doing that, eventually as you enter the data in your classroom, that would all go to this, instant gratification piece that we were talking about. Like, I can see my data that I put up there 2 days ago. So that's kind of already happening, and we just need more people. Like I said, we're doing that in the southeast, and it'd be really easy to share all that information.
And that'd be a great class-to-class collaboration too, online.
Yeah, there
Kids.
you go.
Cool.
And we found out that now we're teaching like 3 different classes at the high school, and then some of the teachers get grief, like, oh, you don't even teach anymore, you just let all these other groups do it for you. It's fun. We have a blast with the kids. We have 4 seniors, and then we've got a handful of other sophomores and juniors. But we do not only the phytoplankton and temperature stuff, we also have a stream wetland ecology course that we're teaching. It all has to do with, it comes all back down to nutritional foods, really, is what we're talking about. So, anyways.
Cool, thanks.
Can I follow that up? I can talk loud enough. Source of funding, Chris. So the key to this is you. The key to this is your organization being willing and able to fund this, and then reach out to you and say, I need students to collect. So, the issue in Kodiak is critical mass. There's just not enough science entities who can focus our efforts in order to get the funding and then maintain that funding. So how are you working with the tribal areas or local coastal communities to A, get their ownership, but B, maintain and sustain that funding? I mean, really, you have to keep going. You've got to provide them with the CTD, et cetera.
Oh yeah. So I am in the same boat. I write gobs and gobs of grants. And maybe I lucked out in the very beginning. I think I wrote 7 and all of them got funded. so I would encourage, like, that's the route that we've used to kind of prop it up in each of the communities. And then we go after larger grants like NSF or BIA Climate to provide a lot of that capacity. So our staff is 6 people, all with, there's like 4 biologists, a biochemist with a PhD, a geologist. We have all these ologists. And then these other communities that may not have that capacity, we get the money and staff to then go in there and keep them engaged in what's going on, or provide at least the supplies and equipment. And so far it's worked, and we've linked up with the schools in these outlying communities too, and that really helps. It makes the tribe, the environmental staff in the village, working with the school, now they share that cool common thing that they're working on, and the kids get involved. It really helps to kind of bridge all those gaps. And then if the staff is off for the day or gone for a week, they've got the teacher that can come in and help pick up the slack on the day, or somebody else. But yeah, funding is the huge question, and I think it's that EPA General Assistance Program. That's what's really got us to where we are, because we don't have to supply money to all the people doing the work. They have their own pot. We just kind of help direct them on how to utilize it the most efficient way to then provide information for the whole project.
That's terrific. Yeah, it's a fantastic program that you've gotten. And so, if I may just keep going a little bit. So the organization that you work for, the organization's goal and mission is to do this type of work. So how does your organization fund it?
So I work for the tribe.
Right.
Yeah. So it's funded through BIA compact dollars, which are mainly used for social services and education. There isn't like a line item for resource protection, which is my department. We have a small traditional foods program that gets like $30,000 a year to provide traditional foods to the elders. And so all the rest of the funding that comes into all that staff I talked about is all grant funded. And that's just how it is. It's all the same stuff that you guys applied for, NSF, NIH, BF. Well, we have a little different with EPA. There's some extra dollars in there we can apply for in BIA. So we have some kind of pigeonhole stuff that CHUNAC can look at and other tribes can look at, but for the most part, it's all soft dollars. So it's scary to get something like this set up that actually is working and people are utilizing it, and it has all this potential, but at the end of the day, it's soft money. And I hope that the corporations will take note of a lot of this stuff and start trickling down some of those dollars. Somebody brought it up. Was that you that brought it up? The tribes? Yeah. So it's like that all over, but the corporations have dollars, but the tribal governments have the people and the burden to provide. But they don't always, at least in Southeast, there's not a lot of collaboration between the tribes and the corporation.
This is good for us to hear, though, for the Kodiak community in terms of an entity. An entity was built by the local community to do what you do. Not folks with other missions trying to piggyback. And I think that's where we need to work together, because you've got a little bit of time and I've got a little bit of time, and maybe we make a person by the time we add up all our agencies. But there's an entity in Sitka that does this.
But we do, and the one person we're missing from our tribal perspective, we're missing many here, but I wanted to get her name right, Robbie Townsend Fennell.
Sure.
They have the forum, the rules forum, and those tribes have come together to discuss their priorities, and they're not always mine. It's okay too. I mean, I'm not saying, I don't think my priority has to be theirs, but we do have that voice, and she's happened to not be here right now. But there have been a lot of projects, in fact, like, maybe my project's not the most important, and that's okay, because especially Sea Grant, I'm trying to be very cognitive of that, just because I'm interested. I think it's a need, and I think that the work in it is showing that it's a need somewhere, but it might not rise to the very tippy top. When I started a number of years ago, especially in Kodiak, there have been efforts towards PSP testing, and what we keep seeing is, donate it, you're above toxic level, donate it, to the point that there's fatigue there. Fort Lyons didn't want to participate. They participated, and they found no value because they were constantly told not to eat it. So why
There's real gray there. I live in that area.
But we've been, okay, even though we're participating in some of these things, we're building capacity, we're not there yet, and now we have a staff of 2, and,
Awesome stuff
Yeah.
too.
and
It's
we're-
noticeable.
Yeah, it is noticeable.
We're trying to build and reach out to other tribes, but collectively, all the tribes on the island are, they have no staff as well. A couple have maybe 1 or 2 people part-time, but there are so many things that come to tribes, like, what's the next asteroid coming in? And they're just scrambling. They're always short on staff and money, and we are constantly watching, trying to write the next grant to keep us going for some of our other work that we're trying to do. And you guys know that.
So how do we write this bigger grant? Yeah, there's a lot.
So.
I saw some hands up back there. Blake?
You're just talking about communication and who do you call and how do you know what's going on. I don't remember when it stopped. I remember that we used to have the environmental working group in
Yeah.
Kodiak, and that was where we all found out who was doing what, so we weren't stepping on each other's toes or we weren't duplicating the same work. I remember the metal hall from the village project came up and somebody wanted to do it, and somebody said, well, let's get together and do it as one project instead of multiple projects. And I hear that the borough just finished it up and it worked. But that started way back when.
I think that came out of the forum too, didn't it? The rural
It
forum.
came out of the forum. I remember it was, I think Woody Island used their ICAP money to fund it for a while.
Yeah, it actually started with the borough. The borough couldn't do it, so the CANA said, hey, we'll help you do it, and that was the connection they needed, because they provided the local people, they have the local contacts, and that's what made it work from the bottom up. And it was successful.
It was very successful.
So maybe read.
Funding was dropped and people moved and changed, and so I would be willing to participate if we're called together again. And I'm sure Robbie would.
Yeah, no, that group was good.
So something I struggle with is what's the definition of community? So, I mean, is a community on a tribal basis for the rural communities around the island, or is it a community in terms of the borough? Is it a community in terms of Kodiak? Is it a community in terms of commercial fishing? Is it just the way of life? I don't know that we've ever defined what community is. And then when you talk about monitoring, you're talking about monitoring because you want to meet the expectation for your project, but as a community, are there things that we should be monitoring that we really haven't even thought about?
No, that's a good,
So,
really good point.
so too many times I think we silo. And so to
Absolutely.
figure out how you could get a community planning group together to figure out how to get our arms around who we are, how we get our arms around about who's doing what, because like you said, there might be people trying to do the same type of thing. And then if we could break down those silos, we might be able to get some grants to meet certain objectives versus but that's the problem, is everybody's so busy in their own life that they can't figure out who's doing what. So I don't know if you could set up a forum to get.
David, isn't this exactly what you're doing?
In the Bering Sea region, yeah.
Yeah. So what does it take to get you here? Or what does it take for us to organize what you're doing? Right, did they have,
So
I mean, that's what you're doing.
Yeah, and it really took a dedicated tribe, the Aleutian Pro-Law Bonds Association, working with the LCCs to do it. So you had that partnership built there, and so you had a tribe lead, and that's one of the unique things about like the Sitka tribe working in the Southeast. They've taken kind of the leadership role of all the tribes in the Southeast, working closely with Central Council Quake and Hideout, and that's what made a difference.
But we're not just tribe either.
And so you're like a mini version of Southeast. You've got fewer communities, but you've still got a lot of capacity here on the island.
So we did function the way with, uniting the tribes, but the benefit goes to tribal and non-tribal. The information isn't just kept within the tribes. It's for everybody. So like in Sitka, we have a lot of tribal members, we have a lot of non-tribal members, and probably half and half of the samples that come in are from non-tribal.
Well, and I can attest that that now expands to the national, international community relative to acidification. The data you guys are collecting is phenomenal. So it's gone beyond just your community.
Oh, yeah, yeah, and that's, you know, it's kind of been just hold on tight, here it goes, because it's been like that. And I can tell you when it comes to grant writing, you know, getting those silos broken down first is going to help get funding, because I mentioned at the beginning of my talk, like the little Sitka tribe tried to do all this, it wouldn't have happened, we wouldn't have gotten any of these dollars. But because we collaborated and had resolutions from these other entities, and we had everybody on the same table, and it was one tribal voice going to the funding source and saying this needs to happen, everything kind of got funded. So sometimes a big collaboration is scary, because like those big NSF grants, you have all these different moving parts, and everybody has their own little agenda. But at the end of the day, those are the ones that get funded and have these big, all these agencies associated with it. So it doesn't have to just be tribes, it could be the city and borough partnering with the tribe as well, it could be the school partnering with this tribe as well. I think the more of that you can show in Kodiak, the better.
I think there are tons of partnerships. I mean, we have tons of opportunities, but the direction, identifying the direction of the community might be our first step. Because
so needs assessment is what I would recommend.
Yeah.
And you could do that through a workshop pretty quickly.
David's got those in his mouth.
I would second what Julie said.
He agrees with you. Did you hear that, Joe?
No, I think I second it. I think we could be so much further advanced here as a community if we, were to have address some of these silos. I understand about the tribes are the ones with really good access, to money and the different grant programs and things like that. But I just think it's time that, given global warming, federal funding, challenges with fisheries resources, productivity, all these kinds of things. The need for young people to be stimulated and engaged at an early time in their life in scientific investigation and understanding the scientific process and what the importance of that in trying to develop our, society, not to get too esoteric here. We've got to do something here, and I think that you have to avoid the kind of unconscious establishment of hierarchies also as you move forward with that.
And the thing that I keep coming back to is we have the largest fishing fleet in all of Alaska right here.
Largest and most diversified fleet.
Right, and so to think about the amount of data that you could collect off the commercial fishing vessels, if you decided what you wanted for monitoring, could be huge.
And then
you'd have to
money.
Well, not necessarily. I mean, you'd have to get the people that I work for, I think would participate, but they would have to understand what the objective was and how it benefits them. And then it's more about the project manager and who's gonna manage the data, but I think the fishermen would just donate the data.
I think there's a couple of scales here. Where I was going and where my thought is always who's that leader? Who's that Sitka Sound group who's going to write the grant and then stick with it, as much as possible, as long as EPA is still there. Who's going to be that leader? And as I was saying, if we don't have that entity that is created to do this, who does it? So in absence of that, I love the idea of a community forum, but that's step one. The community forum, you just mentioned something with the commercial fishing industry. There's a couple $100,000 worth of something. We could come up with 10 more of those. I think I love the idea of the community forum, and then the key is that some entity, if they're not driving the research, they're driving the organization of the ideas that comes out of that. The forum's great at having a bunch of people come in, but then a lot of things go poof. So I think what we need to do then is say, okay, who's the lead on that? There's no one in this town who's the lead on your point. you know, it's someone from outside, someone in Seattle. I mean, again, it gets back to critical mass of who lives in this community, and where the funding could come from. But that doesn't mean that we couldn't reach out and find that entity to gather those data, or.
And I agree with everything here.
Yeah.
And I wanted to hold some kind of fisherman's workshop again with camps again, because we did that a few years ago. But I didn't want to be in the same boat that we had in 2011 when I first started. We had that conversation, but it didn't go anywhere. You know, I wanted an avenue to go somewhere before. It was not right now, but.
But I guess that's what I'm saying. I think if we ahead of time, this group, for instance, says this is phase 1, 2, and 3, so that we don't stop at phase 1 accidentally, or don't lose, you know, energy, or don't wake up and be like, okay, well that's done now. I got to move on to my other job. You know,
Right.
where we ahead of time say these are the phases of making these things work, and think through. I mean, assume you're going to get 20 different ideas. You're going to get 50 ideas. You put a forum like this together in this
But I
community,
think-
you're going to get 50 ideas.
So, but just to kind of follow on to what you said,
Yeah.
the first thing is you'd want to set up the community forum structure to
Yes.
break down the silos to start with.
Agreed.
So that you could get, and then you would move through your phases. But
Yeah.
how to bring as many people together of the right mix.
Yeah, and get scientists together at the beginning and say, okay, what is phase 2? What are we going to commit to as an outcome to these many ideas? How are we going to prioritize them? Because then you have to look for the owner. Because if the ideas come in, you have ownership from somebody. Someone came up with it, it's owner. I mean, you've got ownership over collecting data in a small fleet locally. Great. So now you've got to find that person to lead the need for the data, et cetera, et cetera, et cetera. You know, and obviously you're dealing with that in Bering Sea. You've probably got bigger players and bigger money. So, different scale. So.
Well, and, you know, we all look, I mean, I look to Sea Grant too. I look to Sea Grant and I think that I want to do this, but I'm not sure I have the skills or the capacity to do this big thing. And I hesitate, I don't know how to,
What about getting tribal leaders together, local, and like Skyping with Chris, is your name? I mean, I don't know, just something to get them, to show them the power of what's happening there and kind of what could happen here. Something like that could be in the mix somewhere maybe.
Yeah, I agree. That's a great idea.
Go ahead.
I was just going to say, there is a tribal umbrella organization here called CANA, Kodiak Area Natives Association, but it hasn't worked well with all the tribes and hasn't. But I've only worked for tribes for about 4 years, and I've seen just in my 4 years here more openness to collaborate. And for instance, the Kodiak World Leadership Forum, which is what you're talking about, Robbie Townsend Bennell, that's actually supported by Kodiak Island Housing Authority, and it involves not just tribes, it's to communities. Well, most of our rural communities here are tribal villages, okay? But Canada seems to be taking more and more of a larger role, and they've expressed interest now in working in environmental sciences, whereas traditionally they've stuck mostly with social issues and health issues. And they not only work with just tribal members, they're now the VA representative here for all people that have VA benefits at their Mill Bay clinic. So maybe, you know, like Tyler Cornelius, he has been making some headway on tapping money to do environmental type work at CANA. So that's another place maybe that could be. But again, they're a native organization. Maybe we're talking about a larger, all-encompassing umbrella organization that might be.
Well, and I guess just from my view, it'd be nice to have a professional facilitator that came in and helped you. So maybe you'd have a core group that did the planning, so to speak, and try to get all the silos. And maybe CANA would be the good one for the rural communities. And then have
terrestrial model, Kodiak Strong. They've done 2 community planning sessions, and the first community planning session was December year before last. And one of the ideas, so what happens is you get together, you talk about what can we identify for a goal that will improve the overall health of our community. And we want to see this goal pretty far along within a year, and there's some seed money to get it started. And so the first year, the people in the room brought forward ideas. We, put them on Post-its, put it on a bulletin board, and rate them. And one of the ideas that got the most support was establishing a food co-op downtown, so we don't have a food desert in this area, and having that co-op supplied by local grown produce and supplied fish from fishermen, and then recognizing that it was also desired to have a full stop shop, so that you didn't have to go here to buy your produce and then out to Safeway and Walmart, that there'd be the research done and reaching out to other cooperative established cooperatives that have been successful to make it work, and it is well on its way. The goal is to have 500 members first off before reaching out for additional funding. I think they're at 250 members now, have a board of directors. They're going to be doing another kind of a community kickoff campaign during Comfish. And so we could maybe use that model but apply it to our maritime industry and get get your leadership in the room, wrap your arms around a couple ideas that people can say, okay, these rise to the top. Now let's figure out how to take it to phase 2 and phase 3.
I guess the only thing that I'm thinking, and this is maybe too ambitious, but what we started out as monitoring as a community, but we really haven't talked about what climate change planning and adaptation as a community. So, I mean, would that be one of the goals, which is figuring out the monitoring that we need to take us from now into the future for what's going on in our environment, and then also trying to come up with some deliverables in terms of adaptation, and it could be as much as community planning about our water system, for our sewage system, what might happen with tidal or sea level rise, and it could also move into the marine environment about who gets access to what resources and how we as a community can adapt in terms of the fishing community. Maybe that's too grand, but
I don't think it is at all. KEA's been doing it for a decade. Absolutely. No, I think it's a great idea. Well, they've started. Absolutely. No, I think it's great.
So it's after 5, so you had the first comment, I'm gonna give you the last one.
You started something, sweetheart.
Well, what I've been hearing from all of you, it seems to me like there's a need for a strategic plan that brings all these different groups and their goals together. And I'm kind of missing in here the local government, and that I think needs to be part of the discussion as well. And I've always missed that Kodiak doesn't have a long-term vision.
We might find ourselves providing the local government with that vision.
Right.
Yes.
I don't know that they'll be at the table with us.
And maybe it is the time where tribal governments, scientists, and other community members come together and offer up to our administration, yeah, this needs to be in our strategic plan, and we need to have something. We need to go somewhere.
There we go, that's the last.
And David's going to write us a plan when he goes on the plane tonight.
Kodiak.
He's gonna give us our next step.
Well, I just want to say thanks for everybody for sticking around. And, I think there was something at 6:30.
There is. There's the.
And Quentin's been cooking all day.
Quentin has been cooking all day. There's a lot of food. It's open community reception, so.
What time?
6:30 start. There's always tons of food. Oh, at our building, Kodiak Seafood Marine Science Center.
Good place to go.
I think everybody here knows where we are. Maybe follow we meet again tomorrow for our final session at 9 a.m. So tonight's just a relaxed 8 night.